Hey guys, welcome to Core Java for Test Developers. As you know, Java is the most popular language not just for test automation but also for enterprise application development. The Java language you're going to learn will be your tool for success. This course is designed in such a way that covers the fundamentals really well and understanding object-oriented programming principles with practical examples. As a starter, the most important aspect is logic building. How to write good code to solve a problem. You will spend good amount of time in logic building and doing assignments related to logic building to assure your learning. Once again, welcome aboard. Thank you. Hey guys, welcome. In this lesson, we will discuss about an introduction to programming in general and introduction to Java itself. First, let us see what is programming by definition. By definition, programming is the process of creating a set of instructions that tell a computer how to perform a task. For example, I want to get sum of two numbers, for which I need to instruct the computer to do the math. I want to write a program so that when the user provides a number, in this case two numbers, the computer is supposed to provide a result of those two numbers, right? So once we see how it works out when we start coding in Java, you will get a better understanding. For the concept perspective, let us say my goal is a simple goal, which is sum of two numbers. That's my goal. For that, I had to write a program so that the computer takes one number at a time and gives me the sum of those two numbers, which can be something like this. I will be presenting in a pseudocode format. So enter first number, enter second number. The result is, in this case, the user will be providing whatever the first number is and enters the second number, and the computer or the process is supposed to give the result back to the user. Once you write the program, this should happen every single time for the execution. So once it is written, it can be used forever. Let me show you a simple demonstration of the program we are talking about here. So for the sake of this, I created a program which would be Java fundamentals.java is the file name. So I will run that file and it will prompt me for enter the first number. So we'll enter number 3. Then again it will prompt me enter second number. I will enter, let's say, 4, and the sum of the two numbers is 7. That is the result the program gave back to me. So this is a simple illustration for the programming concept we are talking about. You don't have to worry about how I did that. We will be going in depth as we progress in this course, how I did this and much more than this. But still, to give you a quick idea of what's going behind the screen, is a program was written something which takes a value here as an input, again one more value as an input. Finally, it does a sum, which is nothing but adding these two numbers and giving back to the screen. So this is the process. This is the few lines of code that took care of the little program we ran here in this from the command line. So let's move on to a little more details. What are the fundamental aspects you need to be familiar to develop your programming skill? If you're not very familiar with the programming at all from college or any previous work background, for those who are new to programming, two important things that you need to be practicing and learning is logic building 2 is syntax of the language in which you're going to write the program. So since there are no shortcuts, it's mostly logic building comes from practice. The most important thing again is practice, practice, and practice. So logic building is basically how you would solve a problem. In this previous example, we're trying to solve a problem of adding two numbers. So it should take one number first and again second number. This is basically, you can think it through even before writing the code. The goal is simple, to add these two numbers and provide it as output. So in the program, all we did is take these two numbers and display the result. The logic is very simple in this case, but syntax is what it might be little bit overwhelming for you when you are starting out. In this case, we have a bunch of lines of code which took care of it. Syntax is generally easier than building logic. Once you learn the syntax, you can always search and find the syntactical help online. But logic building is and will be only achieved by practice. I'll be giving you some practice tests that you can do by yourself. For example, in this case, what if you can do a subtraction of these two numbers, and you can do multiplication of these two numbers just by changing this operator right there. So we will do a couple of practice assignments as we go, and from that you can build logic and also learn the syntax. Before we end this lesson, let us talk about Java in particular. Java is a very popular programming language because of primarily two reasons. It is platform independence and object-oriented nature. So what it means by platform independent means once the program is written in Java, it can be run on different environments, whether it's Windows, Linux, or various flavors of Linux. You can run Java on different and multiple operating systems, and it's object oriented, 100% object oriented. We will talk in detail about what is object oriented and what are the main foundation for object oriented principles in the coming lessons. With that in mind, this course is designed to use Java as the programming language to build test automation. So this will help a tester to develop test automation using Java as a fundamental programming language, on top of which we will layer with other automation tools like Selenium and any other add-ons we want to use for developing our framework. With this, I will conclude this lesson. I have two questions for you. One is, what is JVM? And second one is, what is the current version of Java? Thank you.
Hello, welcome back. In this lesson, we will look at setting up your development environment. This is your first baby step into writing your own code. So let us start with setting up your Java environment, which we have chosen to use in our coding, and also setting up Eclipse, which is an editor for writing the code. Eclipse is the most popular editor, which is generally also called as IDE, Integrated Development Environment, because these tools, which I mean IDEs, help us to integrate different components of development, the front-end development and back-end development, such as database connectivity. We can all combine together into one environment and work from there. In this two-step process of setting up your development environment, first, we will check if you have Java installed on your machine, number one. Number two, once Java is installed, we will download and install Eclipse. Let's get started. To check if you already have Java installed on your machine, we can check it from the command line. go to your start programs in Windows and type in CMD, and you get to this command prompt. Click on the command prompt, and once it is open, type in command where Java. If you type in where Java, it gives you the location where the Java executable is located. So in my case, it is located in C program files, Java JDK, the version number, bin directory. So if you don't see something similar, not necessarily exactly the same folder, but if you don't see any kind of Java reference, then you need to install Java, which we will see right now. So to install Java, open up your browser. I'm opening my Chrome browser right here, and we will simply go in here and type in Java JDK download. JDK stands for Java Development Kit. So once we go to the downloads page, typically it allows us to install without signing in. Download without signing in. So we are in this page, and current version is 11.0, right? This is one of the questions we have in the previous lesson. And let us see what else we have. There is 8U version and Java JDK 8 demos and examples. So you can definitely start with downloading this JDK here. This is the latest version, and this is the previous version. Either way, it's fine if you're starting out, but in particular in work environments, there is a requirement depending upon where you work, which version of the Java you need to download. So be specific to that, and you can install that particular version of the Java JDK. So let us say if you're installing this Java 8 version, then I would click on download, and if you're here, select the type of the operating system you want to install on. And before that, definitely we need to click on accept license agreement here, and then I would go, if you're in Windows and latest version of the Windows like 7 or 10, go for Windows x64 and click on the exe. It downloads the file to your downloads directory, and since it's an exe file, which means an executable file, you can simply double click and run and install it. So let's take a look at that. So in the downloads folder, you can double click on the exe file here and start continuing to install Java JDK on your machine. You will see an installer dialog box, and you can click next and select the default development tools, and then click next. Before that, pay attention to the location where it is being installed to. So this is being installed to program files JDK and JDK 1.8 and whatever the minor version is, and click next, and it will start installing on your machine. Once you're done with the installing, we have to run the command we ran before and make sure if it is showing up in the location you are installing it. So let's click OK here, and we are getting one more chance. This is for the JRE. I will talk about the JRE later, but it is Java Runtime Environment. If you're a developer, you need JDK for sure. And if somebody is not a developer but basically needs to run Java program on their machine, they need Java Runtime Environment. They only need runtime environment to run the programs, whereas if you want to develop using Java, you require Java Development Kit. Okay, let's move on with the JRE and click next to install it. Once you're done with installation, you will see this message: Java Development Kit successfully installed. You can simply close this window, and let us go to the command line and see the Java installation location. If you have successfully installed Java, you should be able to see the location of the Java where it is installed, which would be C program files Java JDK bin directory. You can also find the version of the Java you're running, which would be Java dash version, to make sure you got the right version. Okay, with this we will conclude the lesson for installing Java. In the next lesson we will see installing Eclipse and writing your first program. Thank you. Hello, welcome back. In the previous lesson we have seen installing and setting up Java. We did a installation of Java and also verified at which location, confirmed at which location Java has been installed to, and also ran a basic command to find out version of Java after we completed the installation. In this mini lesson we're going to see how to download and install Eclipse. Open up your Chrome browser or any browser and just Google for Eclipse IDE. Probably we can add download, Eclipse IDE download. Then go to the downloads page of Eclipse. There are few choices here, and depending upon our programming path, in our case we will be working mostly with the Java, core Java itself. So I would select Eclipse IDE for Java developers. Though we are meant for using for test development, still it should be considered as Java development. And within this, select 64-bit and click on that. Right now it's spinning up here, and we should be able to see the downloads page for 64-bit Eclipse for Java developers. Here you can hit download button, which would obviously download the zip file into your downloads folder. Once this download is complete, it may take few seconds. We will resume to unzip the file and use Eclipse installer to install Eclipse on our machine. From your downloads folder, you can notice Eclipse Java zip file is downloaded here. So we can extract this file, extract all, and choose a directory where you want to extract it. I will leave the default, which is nothing but the downloads folder and a folder by the name of the zip file itself, the same as the zip file name, and extract it. It seems like it's a big file and moving slowly. Let us reconnect right after the unzipping. Once the unzipping process is complete, you can notice a folder created here. Double clicking on that will take you to the Eclipse, and then you can find eclipse.exe file in it. This is the file which we have to open to get to the Eclipse. Once you open Eclipse, the very first step you would take is to create a workspace for yourself. So that workspace can be anything you want to name it. For now, I will name it as Test Auto and click on Launch. So the Eclipse opens up a workspace with no projects in it, since we did not create any projects yet. So here is the Eclipse welcome screen. You can close that And then the very first step you can take is go to File and do New and select Java project. So for the Java project, I will name this project as Test Automation as the project name, and click on, you can click on Finish, but let's see what options you get if you click on Next. And it shows up the source folder under the Test Automation. Eclipse kind of creates us the folder structure under the Test Automation project. I'm clicking Finish now. I did not do any kind of special selections. All I did is give a name for the project, and then a project is being created with a source folder by default. And if you want to create any kind of files, for now we will keep it simple. I want to create a Java program, very simple program that says hello world, or for change, welcome to Test Automation. So for that, on the source folder, I will right click and do New and do a class, and I will say welcome as the file name. By default it will be public, and I will add public static void main string, which is like the main method. I'll check that and click Finish. So it creates a welcome.java file with an empty method. When I say empty method, nothing implemented inside the method, an empty method. Here what I would do is I will write like system.out.println in quotes, welcome to test automation.co, Control S and a semicolon, and one more time Control S. Control S is a shortcut for saving, otherwise you can click on this little floppy symbol here. So all I did is added one line of code here, and I can simply run this Java file, run as Java application, and it runs this Java file and prints out the message welcome to testautomation.co right here in the console. Great, that's our first line of Java code and implementation of the Java class. So we have installed Eclipse, created a workspace, created a project, created a Java class, and added a Java method, a main method, and added a line of code which prints out welcome to testautomation.co. Isn't that simple? This is where we will end this lesson. You can continue to the next lesson. Thank you. Hello, welcome back. This will be a brief tutorial which will be a supplement to the Eclipse tutorial we already did. I would like to add some more tips and tricks that you need to know with regard to the Eclipse. Eclipse is the main tool you will be spending time working with if you are a software test development engineer. One of the things I want to change is right now we have extracted all of the Eclipse files into the same downloads folder of this PC. I would rather keep this Eclipse under C rather than in the downloads folder. We never know, if you want to clean up your downloads folder for any reason, this is not a great place to put your Eclipse executable in. So what I want to do is move this Eclipse files These are the bunch of the files. This is the main exe, and these are the supporting files for that exe. So I would move these files all together into a C directory, some folder I want to create. So first of all, let me copy all of these files, Control A and Control C, go to the C directory and create Eclipse, my Eclipse, and go into that directory and paste the files of Eclipse. Let them copy it over into this directory so that we have the Eclipse located C:my Eclipse folder. Once the files are successfully copied, now let us go to the downloads folder and delete the folder for Eclipse over there. We no longer need it there, and to avoid confusion which one we are using, it's better to downloads folder and save some space. I'm deleting this folder right here. If you remember from the previous lesson, we have created a workspace by name Test Auto. So we will use the same workspace for now. This workspace has one project, which is Test Automation project. And if I expand on that, we have created welcome.java, and that welcome.java has a main method and a single line of code in that main method, which simply prints out welcome to testautomation.co. This is what we did earlier already. So coming back to Eclipse, few other tips you would like to know is you would like to click on this little arrow, double arrows here, so that whenever I select some file here, it will show the corresponding in the tree structure. So once we have more files, you can see that advantages if you are linking the editor with the tree on the left hand side. And right click is something we have already seen. There are a bunch of options here when you right click. So the most common one, at least for now, is run as Java application is what we want to use for now. So if you click on run as Java application, it basically runs this piece of code and provides the output here in the console. As we advance, we will try to run it in different ways. From command line also is one of the options. And this is the floppy symbol for saving your file whenever you make a change. And project, I would highly recommend going through these menu items here, not so much in depth, but at least to get basic understanding what is available under these different menu items. And one thing I would like to show you is window preferences. This is where the preferences tab is. For now, I like a theme which is darker theme, so I will change it to the darker theme here by selecting theme as dark and leaving it as default, and apply and close. So this kind of changes the Eclipse layout into a darker theme. That's just a preference. If you like the white background, which is default, that is fine too. Here within the main function, one important thing we want to take advantage is Eclipse. Being an IDE provides us some of the very convenience features. Once I type in system dot, it will provide me the recommendations, what you can use as part of the next step. So that is very handy when you are developing any kind of application or writing test cases, so that it kind of gives you an idea of what are the possibilities for using it in that particular context. It is called intelligent help or IntelliHelp. And if you have already noticed, the syntax is color coded so that it's pretty easy for us to understand the code. What are the text goes into the code into one color, and keywords in different colors, which will be very useful as we go through. Two important output tabs are console and problems. If you have some problem within your code, it will show up as part of the problems. This comes in handy if you have like a whole bunch of files in your project and you're seeing some problem running it, then you can easily find out where the problem is. For example, let's try to see if we can create a problem. I removed semicolon here, which is a syntax required at the end of the line of the code, so it's immediately showed up here as a problem. And if I expand on this little arrow, it says insert semicolon to complete block statements. So if I go back and add semicolon and save it, that error should go away just like it did. And console is just an output. Whatever you do to print out, it will show up in the console. This will be very handy in the initial stages of your learning a programming language. So to make sure it's printing out and you are in the right path of the logic or not. With this, I will conclude this lesson. You can move forward now. Thank you. Hello, welcome back. In this lesson, we're going to talk about variables and data types in Java. A variable is a container that holds a value which will be used in the program. In Java, every variable should be declared and it should be initiated with a value before it is used. Now let us take a look. Let us fire up our Eclipse that we installed in our previous lesson. It always prompts for what workspace you want to work in. Usually it selects the one we used last time. So in this case, I'm keeping Test Auto Workspace for now and clicking on Launch. So that brings up the welcome screen. We can close that. And we have our project right here, Test Automation, with a single file, welcome.java, which simply prints out welcome to testautomation.co. Here, let us use the same Java class to demonstrate variables and how to declare and initiate the variables. Like I mentioned, variable is a container that holds a value which would be used in the program. It's like a placeholder. So if I want to save or use a number for summation or subtraction, I need to store them in variables. Let us try to look at a simple example of addition and printing it into the output. Before start coding, let us take a look at how a variable will be declared and what are the various data types. Before that, one Eclipse shortcut for you. I just want to increase the size of the font in the Eclipse editor. You can do that by using Control key and plus sign. Control key, hold the Control key and hit the plus sign so that the size of the font gets bigger. It's much readable now. It will make more sense if we start with a goal. which is nothing but the goal is nothing but, in our case, it's summation of two numbers. So in Java, 2 forward slashes means a comment, so the compiler will not compile that part, so you can add your documentation or any kind of comments you want to add to the code. So here I will add a comment saying sum of two numbers. Okay, and here I'm going to use a variable by name first number. I will declare that first number variable as integer. Int stands for integer. It's the data type, and the name of the variable itself is first number, and I will initiate it to a value of 20. Then I will declare one more number which is also an integer. I will call it as second number, and I will assign a value of 5. Okay, so here these are the two variables we have declared. This part is called the variable, and this part is called data type. So data type indicates what type of data is going to be stored in first number. And if you want to store a double, this is again another type of data type, you can do that. If you want to store float, you can declare that as a float. So in our case, it's a whole number we are trying to use, so we will declare that both of them as integers for now. We will look at double, float, boolean, which are the other types of data types, in a little bit. So we have declared two variables, and we want one more variable to store the sum of these two numbers, which would be int sum of two numbers equals to 0 for now, and we will do the actual addition right below here. Sum of two numbers equals to first number plus second number, right? And here we're trying to print out the value to the screen, so I will do system.out.println the sum is sum of two numbers, right? And try to run this. Right click anywhere in the editor and do run as Java application, and it will print out the sum is 25, the sum of these two numbers. Okay, here you might be wondering, if you are very new to the programming, what's going on in this particular line. Integer declaration, integer summation seems straightforward, I assume. So apart from that, in this tab we're trying to, this is the syntax to print out to the screen, but here I have used double quotes to put the string. Whatever string you want to print out, you can put it in double quotes, as long as it's a string you want to print directly to the screen. You can add it in the double quotes. Not necessarily alphabets, it can be numbers or anything, but which does not require any manipulation. You will simply put it into the quotes and you can print out that. This is more like a convenience to understand what we are printing, just adding a little label to what we are printing to the screen, right? So if I run this, it doesn't make any compilation. It will simply print whatever we added into the codes, right? So here, so this number and the 25 got mixed up, and it appears like a one big number. So I added some space and some funky characters and try to run it one more time to show you it has nothing to do with the actual calculation. Okay, I will remove this unnecessary text from there and rerun it. So I might be going a little slow, assuming there might be people who has no programming background is taking this lesson, so you have to bear with me if you're already exposed to programming. Otherwise, I want to maintain this pace for now, at least for the first few classes. Then I will pace up a little bit in the later lessons. So in this case, we have declared a variable and assigned a value. Okay, you need to get that. So I declared this variable as int data type and initialized with the value of 20. In the next lesson, we will see various data types. I will conclude this lesson for now. Thank you. Hello, welcome back. In this lesson, we're going to talk about data types in Java. In the previous lesson, we have seen int data type. Let us see two more data types, char and boolean. So let us declare, I want to declare char first. So I would do that by declaring data type char, and I want to store capital K in it. So this variable name can be anything. It can be capital KITE, kite, or whatever. It doesn't matter actually. You should use something that makes sense though. So since I'm going to store capital K, I'm naming this char variable name as capital K and assigning a value of capital K in it, and a semicolon is followed right after every statement in Java. So that's the notation, that is the syntax. So I want to print out this particular capital K, so I would do system.out.println, and there is a shortcut. If you can type in SYSO and do control spacebar, it will give you an option to select so that you don't have to type every time. All you need to do is select that, and now I'm going to print this chart to the screen. All I do is system.out.println and the variable name. Let us right click and run as Java application, and we can see K is being printed out here, right? Let us try to store Ki into the variable char. Char variable, you have to mouse over and see the error message it's showing up. It is saying invalid character constant. And if you look into the problems here, if you expand on the error, you will get the same message, invalid character constant, because a char variable holds only one character at a time. It cannot hold multiple characters. That's why it's complaining about invalid character constant. So once I remove that I, it will be happy again without the red underline. So that's the character declaration. And let us take a look at a Boolean declaration. Boolean. This is a Boolean for pass or fail, and this can be assigned a value of true or false, one of those two. So again, I will do the same sys out here and try to print out this value, and right click run as Java application, and it prints out true here. So if I declare it as false, if you run as Java application, it will print out false right there. So booleans hold true or false. Character variable holds a single character, and integer holds integer values. Here's the simple assignment for you at the end of this lesson. Know about other types we have in the data types. So we have seen specifically integer, char, and boolean. Read about byte, short, long, float, and double, and try to work on them. Quite honestly, unless it's a mathematical application, you won't be working on the remaining data types a whole lot. You will be using integer, char, boolean, and string, which we did not discuss yet. These 4 data types more regularly than any other data type. So with that, I will conclude this lesson. We'll see you next time. Thank you. Hey guys, welcome back. In this lesson, we will talk about code and data, Java class top to bottom, which covers all of the components in a typical Java class file. This should give you a good understanding of various components in a typical Java class file. As we know, Java is comprised of class files. It's a combination of many class files, makes it a Java application. So we will take a bite size and jump into details of various components within a Java class. In simple terms, a program is nothing but a combination of data and code. So basically what we are trying to achieve is feeding in information, the data into the program, and getting an output. So any typical program or application deals with data manipulation, data order changing or format changing, and providing into a newer format. So if we consider a program, it is nothing but a combination of data and code. So a typical program, it can be written in any language, not necessarily Java. So all it does is primarily it takes in the data and processes the data and gives the output, again the data, right? So here we are dealing with data, code, and data as an output. In simple program that we did, which is a simple sum example, adding of 2 numbers, adding of x plus y and giving the total. That example is a simple example. What it does is it took the values of x and y and gave us the output back. If you take more advanced or more complicated examples, such as a website, the primary thing it does is this is your browser and this is your server, which is sitting somewhere. Once we make a request, we are sending data to the server, sending whatever the form elements we are submitting from this browser, and the server receives the data. For example, you logged in here, and server takes that login information and retrieves the data which is relevant to you, that is sign you in and show you your welcome screen back to you, right? It is sending the data back to you. So the program which is running here is primarily dealing with taking the data and responding with the data that is relevant to the input. So in simplest form, we can tell a program is a combination of data and code. Java is completely object-oriented language. So whatever you write in Java should be part of a class. It cannot be outside of a class. For example, we have written code for summation, adding two numbers. That's part of the class file. So everything, any code you write should be part of a class. Only two things that stay outside of a class are package and import. We'll talk about package and import in a little bit. As far as class is concerned, different things, that elements that consist in a class are variables and methods. So when we write a class, we need to make sure all of the code is within a class. The source code file is stored as .java. Once it is compiled, it will be converted into .class file. So this happens behind the scenes. If you want to look at .class file, it is not readable. It's a compiled form of the code, but you can open and see a .class file. So .java is where we write our code. Let us get into an Eclipse and start working on writing a brand new class and declare variables and write a method and include a package and an import. Let us see the whole process of a single Java class file. We will create a brand new class and go through each section of the class file in our next lesson. Thank you. Hello, welcome back. In this lesson, we will discuss about access modifiers. In Java, we have 4 different access modifiers. They are public, private, protected, and default. First of all, what are access modifiers? Access modifiers are used to specify the access level for a given class or variable or method or constructor. So constructor as of now is a new concept for you. We haven't discussed constructor yet, but you know variables, you know methods, you know classes, right? So if you are declaring any one of these, there is an access modifier in front of them which indicates its access level. When we say public class, that means that class is available to be called from anywhere in the Java application. And if you declare a class as default, that is available within the package, within the class, but it is not available outside of the package. So we have also discussed about the package. All of the classes that hold together or similar functionality, we will keep them in a package, a relevant package. Think of package as like an organizer. So all related documents will go into a particular file, and let us say tax documents go into tax file, and investment documents go into investments folder. So we will organize the classes into different packages. So here the concept is what level of access that particular class, method, or variable has is defined by access modifiers. Let us take a look at some basic code to understand this. Here I have created one class by name access modifiers. But here what we need to look at is this part. Every class will have a keyword in front of it which indicates what is the access modifier for that class. In this case it's a public, and this can also be nothing which will be considered as default. So for now let's keep the public as the access modifier for this class, and then again I will declare some instance variables which are employee name and salary. So for employee name, I will declare a variable string, and employee name is the variable name. So with this, and also let us declare salary for that employee, which we can give it as an integer. The variable name is salary. So far we have used access modifiers at a class level and also for an instance variable. And next thing I'm going to do is use the access modifier for a method name. So add new employee is the method name. For that I have used an access modifier as public. I will also create one more method which is private this time. Private void. Void means nothing will be returned from this method, and calculate salary with bonus is the method name. So here we have used access modifiers public and private. So this private method is only accessible within the class. Since it's declared as private, you can make a call to this method from within the class and access that method. But we cannot access this method if you instantiate access modifiers object and try to call calculate salary bonus directly. You cannot do that. You can call add new employee, which in turn calls calculate salary bonus. So access modifiers control what level of access we give on a class, a method, a variable, and a constructor. All four of those. So in general usage, we will be more focused on using either public or private. Protected and default. If you don't declare anything as default, anything as an access modifier, it is considered as default. Whereas protected, you have to explicitly declare it as a protected. So here in this particular class, in general practice, as a best practice, you don't want to declare your instance variables as public. They should be always private, and you need to give access to these variables only through the methods. So you don't want to put your variables as public, which are directly accessible to other classes. This is based on one of the OOPS concepts which we will be discussing in the future. We have two classes dedicated for OOPS concepts, so that we will go in detail what are the best practices and see an example for each one of the OOPS concepts. And circling back to access modifiers, so you have to remember those four types of access modifiers, and they control the access of each one of the four elements of a class: the class name, instance variable, method name, and constructor. Let us take a look at the definitions now. So for public, it has no restrictions. Data members, methods, classes that are declared public can be accessed from anywhere. Private is only accessible within the method. In the earlier example, we have declared salary bonus as private, so it is only accessible within that class. You cannot call that method from outside of that class. And default is like if you don't mention any access modifier, it is considered as a default. And protected access modifier is within the package and outside of a package only through inheritance. So this is interview question, so you have to be aware of this. But even though at this point of time you don't know what exactly it means, just keep that in mind for now. A protected is something which is accessible within the package and outside of the package through inheritance. Inheritance is one of the OOPS concepts we will discuss in coming classes. And one more time to summarize everything together, let us take a look at the table. So this is the table here, access a modifier type, and what is the access level. Within the class, all of these are accessible. Within the package, outside of the package subclass, which is nothing but inheritance, and outside of package, these are the tabular format you can go through, but don't get overwhelmed by different types of combinations. Here the most important thing is the common usage one is a public and private. So from the testing perspective, from test development perspective, these are the main two things we will deal. With that, I will conclude this lesson. You may now move on to the next lesson. Thank you. Hey guys, welcome back. Here I'm opening up our Eclipse and selecting the default workspace. So in Eclipse, I'm going to create a brand new class, which we are starting with this part right here, declaring a class. We will come back to all of the elements here, but let us start with creating a class. So under the default package, I right-clicked and adding a new class. For this, I will name it as top to bottom. And here I'm not selecting anything else for now, just giving a name to the class, top to bottom, and finish it. You can see a class top to bottom .java is created, and with the same name, a class is also created. Okay, one thing you need to be aware of is the class name, whatever the Java file name, should be same as the class, the outer class name. So if I want to name it as top to bottom one, either I need to go back. You see the red X symbols here, the little X symbols? That means it is not appropriate or legal to do that. So either I have to change the name of the file to top to bottom one, or just remove this one. So that's a convention we have to follow. The name of the .java and the class file, the class name should be the same. This is the common mistake people will be wondering. They will create some class file and then they will try to give a different name to the class name. So you have to be aware of that. So we have created a class here, and now let us declare some class level variables. Okay, here I'm declaring an integer age equal to 0. I'm initiating with the 0 value for now, and I'm also declaring one more variable, private string name equal to something empty, or you can do null, any one of those. So we have declared a class and we have declared class level variables. They are also called as instance variables because they will be at the class level. Whenever you create an object out of this class, they are available as part of the class instance. So they are also called instance variables. So we have declared a class and class level variables. Now let us create a method. This is where it gets interesting. So I'm going to create a method by name. I should have a goal in my mind what I'm doing. So let us create a method which is a summation of two numbers, or a multiplication of two numbers this time, just for a change. So I want to create a method multiply. This is the method, and curly braces is the syntax for methods. For now, the return type is void. If if we haven't discussed about the return types, we will do it shortly. So here the method is an action upon the data. Variables are the data, whereas a method is an action upon, like whether it's a multiplication or addition or whatever we are doing, any kind of action we take on the data will be part of the method. So we have declared a class level variables, and a method. Here I want you to pay attention to the syntax. Syntax can be confusing when you are starting out. So for variables, you will not be using this parenthesis. You will be simply declaring variable and assigning an initial value. Even if you don't assign an initial value, that should not be a complaint from the editor. That is still fine. But if you notice, for the variables, we are not using parentheses, whereas for methods, we use a parenthesis right after the method name. And always a method will have a curly braces followed by that. Okay, so here we have these variables and a method declared. Now let us see what is a method signature. Okay, so method signature is whatever that goes into these parentheses is the method signature. That means whatever the method takes, the values is the method signature. In our case, we are trying to multiply. So for multiplying, at least let us do with two numbers. So with that in mind, I will accept two numbers as parameters. Pay attention to the keywords. Parameters. One parameter, I'll call it as number 1, and another parameter, I will call it as number 2. Okay, so we are accepting two numbers to multiply, and these are called parameters, parameter 1 and parameter 2. The whole combination of parameters is called method signature. Okay, so the whole thing, if you have 2, 3 or 4 or 5, it doesn't matter. The whole thing is called method signature. And now let us talk about method return type. So once the method processes the data it received, it can return the value back to the calling method. So whatever the program or a method or is calling this particular multiply, there's a typo. So whatever it is calling multiply, that can get back the result back. So that is called the return type. If the method is not returning any value, you can simply say void. That means no return type exists. Okay, let us try with no return type exists first, and then we will return a value. Now this particular one, number 12 item here, method variables. Inside the method you can declare variables. You have declared variables at a class level. In the similar way, you can declare method level variables. If you can think of the only one variable I may require here is the product of these two numbers, right? So the product of these two numbers is what I need. So for that I will declare a variable int product equal to 0, and then this part you already know from summation we did. The product will be a multiplication between number 1 and number 2, okay, and a semicolon. Every statement in Java ends with a semicolon. So this asterisk represent multiplication. Hope so far so good. Let us see here. We will try to print out the value right here within the method itself. So I will add syso You can type in CISO and do Control spacebar in Windows. Then you can use the shortcut to copy the value. You don't have to type in. Product is whatever the value that's been calculated. Okay, so this is where we have created method and did a multiplication and printing out. To really print this out, Java needs a main function. So Java compiler does not care about the methods and classes unless it finds a main function. Main is like where the Java needs to start executing. Without main, you cannot run this particular class. So if I do run as, you will not get an option to run at all in Eclipse also. So what we can do is we can add a main method, which is the entry point into the Java, and here I would call the multiply method by passing in two values. So let us say I will pass in 2, 3 semicolon and save it. Here you can notice it's complaining about change multiply to static. This is a concept in Java where a static method can only call a static method. So I have to change multiply to a static method. So I can simply click here to change it to static, or I can type it by myself. So I'll just click here, change multiply to static, and once it is changed to static, the red complaint went away. Now let us quickly run this. Run as. You can notice the main Java application appeared again. Click run, and you will get the product is, which is being printed out from within the method itself. Okay, so here is one thing I would go in a different session is static. It's an interview point also. It's an important concept. What is static and why we need static, we will discuss later. Don't get carried away by that. Just focus on class, methods, class level variables, method level variables, and return type. Okay, so we need to cover one more aspect, which is return type. So which is the return type here, right here. So return type, we declare it as void, but I want to change this to int. Okay, so I'm printing in this method here, but what if I want to print or take that value back to the calling method, which is main method? What if I want that value here in this method? Right now I cannot. I don't have access to the product in this method, but for some reason I want that product value to be available in the calling method. Then I need to pass it back that value to the calling method. So main here is the calling method and multiply is the being called method, right? So multiply, we are calling multiply from within main. So main is calling multiply and the product is printed out here in multiply. For my requirement, I want that multiplied whatever the product value available in main. So right now it is not available. If I want to make sure that is available, I have to get it back from multiply. Then instead of saying void, I should say some data type, whatever it is being returned. Since the product of two numbers is also an integer, I will put the data type as integer. So since it is an integer and we are not returning any integer here, that is why it is complaining. Always pay attention to the error message you get in the editor. Okay, so here it is saying this method must return a result of type int, and it is also suggesting add return statement or change return type to void. We don't want to change it to void. We are coming from void to integer right now, so this is not an option. Then I will choose the first one, add return statement. Okay, I will add a return statement, and it by default intelligently selected product. That's what we want to send it back. So now we not only printing within the method, but we are also returning the product to the calling function, which is main. So I'm getting the product value back to main, but within the main I'm not catching it, right? So I need to catch it by declaring an int and giving some variable. Not necessarily should be the same, so that is why I'm changing slightly to product value. So here I'm catching that value which is being returned here by using this variable, and I can simply do a sysout control space printed from main, just to indicate the difference where it is being printed from. So here I'm trying to say that it is being printed from main. So here if we run this one right now, run as Java application, product is 6, which is being printed here, printed from main, printed from main. So the value is again printed from main. You see the return type, how it works. If you declare it a return type, then you need to use a return to send back the product via the return type to the calling function, and the calling function should catch that value so that it can use it as an input for something else. The possibilities are unlimited, but the requirement varies. In some cases you don't have to return something, in some cases you have to return something. In both the cases we have seen an example. Now this is the hardest part. You covered one of the hardest part, dissecting the class. Instance variables, method variables, methods, return types. Very critical aspect of a class, a Java class file is covered here. The other two topics we need to cover are simple, which are package and import. We will see package and import in the next lesson. Thank you. Hello, welcome back. In this lesson, we're going to talk about class and object. In object-oriented programming, classes and objects are very core principles. So far, we have created many classes, but we never paid close attention to what's happening, and also we never converted a class to an object. In this lesson, we're going to see the definitions and also create objects out of classes. And towards the end of the lesson, we will see constructors. What are constructors? Why we need them? We're going to look into that with an example. A class in Java is a very basic building block, and for that matter in any object-oriented language. It is like a template where you will define the data and also behavior. That means the actions you take on that data in a class. When it comes to an object, it's a combination of data and procedures working on that data. An object will have a state and a behavior. That is the main difference. Whereas class is a description how an object should behave, whereas an object is actual representation of the class which has a state and behavior. I will give you an example. For a house, you have a plan how to build a house and various dimensions, not just the length of the room, width of the room, but also other components of the house, kitchen and gas connections. Multiple things are there. So everything will be described in blueprint of the house, right? So everything is in detail in the blueprint of the house. Then once the contractor start building the house, they will go according to the blueprint and build actual house. So using that blueprint, you can build n number of houses, 10, 20, 30. Once you have that blueprint, you will be building a number of houses. So in this case, a class is a blueprint, okay, which describes how the actual house should look like, which is an object, right? So a class is a blueprint and house is an object. You get it? So that is the main principle behind classes and object. Now, when you look at this picture here on the left side, which is a blueprint of the house, which is like a floor plan of the house, and this is an actual house. So in our case, class is something that describes how the house should look from interior and also exterior. Here I'm representing only the floor plan, and there might be additional details for building this object at an high level. So it should have a front porch and master bedroom, great room, deck, dining, kitchen, and the bedroom, bath. All of the details are there here. This is considered as the blueprint for building the actual house. The actual house is the object. So the process of converting a class into an object in Java, it's called instantiation. Okay, this is the keyword we need to be aware of. So instantiation is a process of converting a class into an object. How we achieve that is, for example, we have a class by name simply as house, okay, and I want to use this class and create an object. This is achieved by using a syntax which I'm going to show you right here. So I want an object house. I will name that as my house, and that can be instantiated by using a new operator and house. So I'm creating my house using the blueprint of which is this class right here. So I can create n number of my houses, my house 1, my house 2, my house 3, any number of house objects by simply using the blueprint of house. Okay, so the process of converting a class into an object is instantiation, and using the blueprint of a class you can create n number of objects. So in Eclipse we are going to see an example, and we will use employee as the blueprint, a class, and I will be creating n number of employees using that blueprint. Okay, let's move on. In Eclipse, I'm going to create a new class by name employee, so which should have certain properties. That properties can be employee's name, salary, and department. So I will declare those variables which represent name, salary, and department. Private string name, private int salary, private string department. With these variables, I want to do an operation, a behavior on these variables. With simply these variables, I'm not going to achieve anything. So I want to add a name, get the name, add salary, get salary, add department name, get the department name, right? So if John Doe is an employee, that I want that object to represent John Doe, his name, his salary, and his department. Let us do that. I will start with the name, setting the name. So public void set name if you are setting the name, you need a name. So the parameter for this method is receiving the name. To reduce the ambiguity, I will modify employee name, the variable name as employee name here. Or we can use this operator, which I don't want to introduce at this point. Let us focus on simply variables and methods. Okay, employee name equal to name, and then similarly I want to get the name of this employee. Eventually, if I want to find out the details of the employee, I need to get the name. So this time I'm getting the name. So name is of what data type? String, right? So the return type should be string. Since it's getting the name, this method is going to return the name, and it is getting, so it doesn't have a necessity to send a name. So here getting a name, and here we need to return the name, which would be employee name. Okay, so far I created two methods. One is set name, another one is get name, okay, for an employee. And similarly we have two more members, salary and department. So Eclipse provides a very efficient way of creating these getters and setters. In this step I will use that. It is pretty much similar to how we wrote these two methods. Right click on salary and go to source and click on generate getters and setters. Okay, and this window pops up. Here you can select for which member variables you want to create getters and setters. Since we already did for employee name, you don't want to select that, but you can select salary and department. I selected both of those, and here access modifier, I'm leaving it as public and clicking on generate. If you notice, there are a bunch of methods created for us. Let us sort it out. First of all, you want to keep all of your variables at the top. It kind of created in the middle of those variables, so we can move around. The first and foremost thing we did was methods we have created is set and get name. So I will take them, Control X and Control V at the top. And now let's take a look at the methods that Eclipse created for us. Here is get salary, set salary, and here is get department and set department. At a micro level, all we are doing is we're establishing this employee profile, right? It's the blueprint. It is basically what does an employee object should have. We are defining that in this class. Okay, so we went so simple. We are only using employee name, salary and department, and we set and get those values from this object. Now let us create an object of employee. Right now I cannot set and get unless I have an object of employee. So what we can do here is to create an object. I'll create a main method. This is the interesting part. So I want to create employee object, right? The syntax will be like this. So here we created an employee object, which is EMP, which is of data type employee. And new is the operator that creates an object out of a class. Okay, Let us take a look at the steps involved in creating an object. So there are 3 steps involved in creating an object. One is declaring an object, then instantiation of an object, and initialization of an object. In our code in Eclipse, we have combined declaration and instantiation into one statement. You can separate them, but what we did was we simply did these 2 steps together in one statement: declaration and instantiation. Now let us take care of the 3rd step, which is initialization of the object. Since our object EMP is declared and instantiated, now let us initialize with values. EMP is the object dot set. Once I type in set, you can notice 3 of the set methods appeared here. They are filtered and it gave us available methods starting with set. So I want to set the name, and also I want to set department and salary. I'll set the name to John Doe. Department as IT, and salary as 4,000. Okay, I'm trying to match the data types. So name is of data type string, and department is again string, and salary we declared it as integer at the top. So this object employee is created now. Let us test this object and get some values out of it. So employee dot, now I am using get name, which does not require a parameter, right? It just returns the name of the employee. Similarly, I will do for salary and department. Simply getting it, we will not be able to see on the console. So let us do a system.out. I will run this Java class, run as Java application, and we can see all of the 3 values are printed out into our console. John Doe IT 4000. So in this example, what we did is we created a blueprint of class employee, and we have set the methods for name, department, and salary. And then we created an object of that class using the new operator, set the values, and got the values back. So the biggest advantage of using objects is you can consolidate the information and also behavior into a single object. Employee can have multiple properties and behaviors, but you can simply store everything into a single object. For example, this EMP has endless possibilities. It can store name, department, salary, social security number, hire date, type of contract, whether he is full-time or a contractor, geographic location, reporting manager. You can see the possibilities are unlimited. And everything can be carried out in a single variable. If I can pass this to anywhere, it will have all of the information that is related to that employee. And you can also create n number of employees by using this blueprint employee class. I can go down here and create one more employee with a different name, obviously employee 1, and set the name to Jane Doe IT and the salary. So you can create any number of employees and you can expand the properties of the employee also. When we look into object-oriented concepts in the next coming lesson, we will apply a lot of those concepts using objects. With this, I will end this lesson. You may now move on to the next one. Thank you. Hey guys, welcome back. In this lesson, we're going to discuss about POJOs. POJOs are plain old Java objects. We will learn why we need POJOs, when we will be using them, and how we will be using POJOs. So let us start with why we need them. You can create a POJO representing a person or thing or a process. Let us say a person employee. Now you can set employee name, date of birth, SSN, etc. If you take a thing like car, you can set type like coupe, sedan or SUV, and you can set transmission type automatic, manual or Triptonic. So these are the different types of objects we have, whether it is an employee or a car or a process. An example for a process is a banking process. So make deposit, withdrawal, cashier check. So these are the various processes that are part of banking system. These processes can be represented part of a POJO. When to use them? Whenever we want to refer to a thing, process, or a person which has relative functionality, you can create a POJO object out of it. So if I want to collect all of the information related to an employee, I would create an employee POJO. So the reason we are covering this topic of POJOs as part of Java for test automation developers is they are useful in storing multiple sets of data for a similar type of objects. You can store multiple employees of similar object. The object is same. It has the same name, date of birth, salary, department, properties, but you can store multiple of them. And the second reason is more futuristic. When we are developing automation tests in the future using Selenium, we use a concept called page object model. Knowledge of POJOs makes it super easy for you to understand POM, which is page object model. People who are learning POM and POJO at the same time will have trouble understanding it. So we are kind of covering the POJOs now, and we implement this when we are doing Selenium automation. Here is the definition for a POJO. POJO means plain old Java object which contains only private variables and corresponding getter and setters. Simply, it is a normal Java class. It does not contain any kind of business implementations. So it's a plain Java class with setters and getters and no business implementation, no business logic included in these POJOs. The important thing to note down here is all the methods must be public. All instance variables should be private and should not extend pre-specified classes. That part we can keep it for later because we are learning POJOs from the standpoint of using POM object model in the future. So we are not strictly implementing POJOs, but to understand how setters and getters work, that is a key thing, right? That is a very important thing, how setters and getters work, and why we want methods to be public but not the instance variables. That's an interview question. If you declare a class in a Java, why you want to keep the variables private and methods public? Those are the two important things we are going to understand as part of this lesson. Now let us open Eclipse and create a POJO for an employee object. So under this Java Fundamentals package, I'm creating a new class by name Employee POJO for now. So here I'll keep the defaults here and click finish. So a class was created for us. Two key aspects we need to remember. One, the instance variables should be private and methods should be public. So let us start with instance variables. So an employee, think of an employee and associated data. Employee name, department, and age. These are the three fields we will start with. For these three variables, I will declare instance variables, private, so with those variables declared, check this particular thing I am doing. If you right click and go down here, source, this seems to be going little off screen. Let me adjust that. So in here I will right click and I will go into source and select generate getters and setters. Okay, I'll click on that. You can manually type it, but this is a very convenient way to generate setters and getters in Eclipse. So once I do that, this window comes up and you can select multiple instance variables that you want to set both getters and setters. So I will leave this as a public. That is one of the requirements, and click generate. Now if you notice, we can see setters and getters generated for get name, set name, get name, set department, get department, set age, and get age. So this is a way where you can use built-in Eclipse functionality to generate setters and getters for an instance variable. Otherwise you can simply type, that's also perfectly fine. Now let us see this POJO object that we created in action. That means we want to instantiate this object and make calls to all of these setters and getters. For that, I will create one more class which is like a calling class, and I will name it as POJO caller or employee POJO caller. So this method, all it will have is a main method that instantiates the POJO object and make calls to it. So in the real world, think of some other class calling this Pojo and creating bunch of employee objects. So here we want to create the employee Pojo. So simply I will start with creating a main function so that we can make the calls to it and run the Java. Control spacebar main. Let me do it again. Backspace control main control spacebar and select the first one. Here I will instantiate the Pojo object, employee Pojo. Now you can make calls on this object. I will fill in this information. So we can see here one employee object is created from this class, and we can simply create any number of objects you want using the same class. So I'll copy paste and change the object name a little bit and probably the names also. Since we have used all setters, let us try to use a getter and print it out to the screen. For that, I will call get name for each object. So to really print it out to the screen, we need to use the sysout, SYSO, control spacebar is again a shortcut. Now that we have this getters set up, let us run this Java class and see the output. Run as Java application, and once we run, we can notice John, Mike and Sita has printed out into the console. So we have created 3 objects, used the setters and also getters. So with the setters and getters, we're giving access to this instance variables through the methods. Now the biggest question, why don't we make those instance variables public and let the object access them directly? Simple answer, that's not a good design principle, that's not a good design approach. And lengthier answer is, it's like giving the access to an instance variable without validating what kind of data it's been assigned to. Let us say employee means of age 18 and above. And if we are making this instance variable public, let us assume we are making it, you're not supposed to do it, but let us assume we are doing it. So I will make it public, and you can go here and you can assign the value of age. So somebody can assign the value of 2-year-old as an employee age, right? So you don't have control over what kind of values has been assigned. If it is coming through a method, you can definitely validate that. Let us try to run this case and see. And before that, for the sake of this example, I will also add sysout for age here. So I have added the sysout for the age, and if I run this, we can see John age was printed out as 2 years. So this is happening because we are directly giving access to the instance variable. But if it is coming through set age, let us assume that. For a moment I will comment out that, and you can still assign 2 here, but the real power comes, you can go into set age, and here you can validate it before you're adding it to the assigning it to the instance variable. So I can do if age greater than 17, then only make this value assigned to the instance variable. Otherwise, give a message, the possibilities are unlimited. Either you can assign a default age, or you can give a message back, whatever you want to do. For the sake of this example, we will simply send or sysout a message invalid age if the age is less than 17, and a default age of 0 will be assigned to it. You have to be careful with these curly braces, making sure we are opening in them correctly and closing them correctly. And so if age is greater than 17, assign it, else assign a 0 value to the age and print out as invalid age. Now let us try to run this with a value of 2. Now we can see invalid age has been printed out and a default value of 0 has been assigned. So this is just for the sake of example. You can assign a value, or you can simply stop the entering of those values and throw an exception. That's out of scope of what we are talking about here, but we want to understand here the power of using methods to access member variables is important, so that you can validate the data before it's been assigned to instance variables of that particular object. So this concept can be used in page object model in Selenium down the road. To conclude this lesson, we have seen 2 primary advantages. One is POJOs can be used to create a collection of objects with similar functionality but different data. So we have multiple employees who has a similar type of data but not same data, and that's number 1. Number 2 is we have used methods to access instance variables by using public access modifier for methods and private access modifiers for instance variables. So instance variables should be always private, and the methods can be public or private, but in this case we have used all of them as public because we want to set the values and get the values. Okay, with that I will conclude this lesson. You may now move on to the next one. Thank you. Hello, welcome back. In this lesson, we will discuss about main method. We have been using main method in our previous lessons. Let us dissect a little bit more into this method. What is main method? Why we need main method? And how to use it. The main method is the entry point into any Java program. The Java virtual machine look for the existence of a main method to start the program. If the JVM does not find a method, it won't run the Java application. Once we compile the code and run it, the JVM scans all the files and look for the main method and start executing from the main method. So the main method is crucial, otherwise we will not be able to run the Java application. So if you look at the syntax which we have been using, it consists of public, static, void, main, and arguments are string array. So if you look at each individual element of this method, public is the access modifier. We have discussed about the access modifiers. Access modifiers define the scope of a class or instance variable or method or constructor. So in this case, public means this main method is available, visible globally in the application. The second one, which is static, which we haven't discussed much about it, but it is basically saying this method can be called without instantiating the class. When we discuss classes and objects, we will understand what is instantiation means. And moving to the next one, void, which is this main method does not return anything back, and the main itself is the name of the method. So main is the name of the method. If you name it something different, JVM will not be able to find it. You will not get any error, but JVM will not be able to find it because it's specifically searching for main as exactly as it is. Then once the JVM finds this main method, it will execute the code whatever it is written inside that main method. Let us quickly look at the code in Eclipse. In this Java fundamentals package we already have, let us create a new class by name main method demo. So we have this main method demo here. One shortcut you have is main control spacebar. The second one in the list, main method, you can select that, or you can simply type the whole thing. So here this is the main method by default. This is what we require to start the program, and I will add just a simple sys out for now. This is demo of main method. Save and right click, run as Java application, and you can see this is demo of main method in the console. So let us go here. This is the access modifier. Again, this is the static keyword which indicates this method is accessible without instantiating the class. If you don't understand, you will understand in the upcoming class about the static. And void, which you already know, which means this method does not return anything. And the main is the key method name, which is understood by JVM. And here we have one parameter, which is array of strings. So which takes array of strings as input into this method. This we will do it when we are doing writing to console and reading from console upcoming lesson. And let us see, this is good. I was talking about JVM understands only the keyword main. It looks for the main method. If it does not find the main method, it won't run the program, right? So let me change this to main one, okay? And save it and right click, and you won't even get an option to run as Java application. Right after you switch back to main, then and try to run it, then you'll get an supposed to get an option here. Let me see, I did not save it properly, or I completely deleted it. Let me put it back. Control S to save it. Right click, run as. You can see Java application, run as Java application here again. With this, I conclude this lesson. You may now move on to the next one. Thank you. Hello, welcome back. In this quick lesson, we will discuss about constructors and using this operator. Constructors are used to initialize the object state. In our previous lesson, we have created an employee object and added an employee John Doe and salary and IT department as individual steps. If you use a constructor, you can do that object instantiation in a single step. So a constructor should be of the same name as the class name, and it will be the first method that will be called when you initialize an object. Let us take a look in Eclipse how we can convert our earlier program of employee creation using construct. I will make a copy of employee.java file so that we can have one class demonstrating the regular setters and getters and one class to demonstrate constructors. I'll copy employee.java and paste in the same package and give it a name employee C. Just to make sense, it's using a constructor. Like I mentioned earlier, constructors are used to initialize an object. So in the previous example, we are initializing an object by using set name, set department, set salary here, initializing with values. So for now, what we will do is we will create a constructor in employee class file. We will create a constructor in employee and use that constructor to initialize the values. The requirement for creating a constructor is it should be the same name as the class name. Here our class name is employee C. We have to name the method as employee C to make it a constructor. I'm creating a method that will be a constructor. So public employee C, open and close curly braces. To make sure we arrived into the constructor, I will add a sysout statement. Let us run this main function and see what output we get. If you notice here in the output, we can see I am in constructor of employee C has been called twice. And explicitly we never called that method in our main. Our main is instantiating an employee C and instantiating an employee C object here 2 times. And when I say we did not explicitly call, means I did not do emp.employee C. I did not do that. So since it's being a constructor, it gets called automatically. Java will find if there is a method exactly same name as class name, and if it doesn't have any return type, it considers that as a constructor and calls that by default. So what is the use of constructor? One of the main usage is if you don't want to expose any methods of your object, you can simply expose only the constructor. Whoever creating an employee object will be calling the constructor and setting up the values. For example, in this case, if you are adding employees and if you are not providing John Doe the name of the employee and trying to add set department and set salary, it will allow in the current functionality. But I want to restrict the user to provide all 3 values when he is creating this object. So it's like using a main door only to allow somebody to enter into the home rather than other back doors and side doors. So instead of allowing the user to set individual values, I will make sure they will come through the constructor and create the object. Let us modify the constructor to accept the values and create the object. We can start accepting values into the constructor. So I will declare the parameters we want for an object to be created. And in the constructor, I will assign the values to the instance variables. So here we took the parameters and assigned them to the instance variables. And once I save it, I see a complaint here. Let us see what it was. If you go down here and mouse over on that, add arguments to match employee, because the constructor of this class is now expecting 3 parameters and we are not passing them into the constructor. So that's what it is complaining about. So we need to start passing those values here. And since we are using constructor, we no longer want to use these setters. For the simplicity purposes, I will try avoiding the second object so that we can focus on one object which is taking values through the constructor. So let me save it and run as Java application, and you can see I'm in constructor is called and the values were successfully passed through the constructor to the object, and we were able to print it out using getters. Since this approach is through the constructor, all of the values are being sent in a single statement. So in this statement, we are initializing and instantiating the object. We are initializing with John Doe IT and 4000 as the values, at the same time when we are creating the object emp. So two things are done in the single statement. So we no longer use set name, set salary, set department here. That way you are forcing everybody to pass all three values to really create an object. Previously you have this flexibility. You can simply create an object and set only the name or only the department name and salaries and no employee name. That object is useless if it does not have an associated employee name, right? So right now we are using constructor that is strictly requires you to pass all three values to create an object. So if I try to create an employee 1 and if I don't pass the name, it will complain about it. So it won't compile. It would say add argument to match employee string. So the constructors are a mechanism where it gives you more structured way of creating and initializing an object. So constructor eliminates the necessity to call normal method implicitly. You don't have to call set multiple times for each individual object you're going to create. It gets cumbersome or more work if you're doing multiple objects. Now it can be simply passed while you're instantiating the object. In the same context, let us look at this operator. This operator is used in Java so that it will act as a reference to the current object, the object whose method or constructor is being called. In our case, we can go back into our constructor here and add this operator in front of these variables. This dot employee name, this dot salary, this dot department. So this operator will reduce the ambiguity of which variable we are referring to. If we are simply saying employee name equal to name, in case of inheritance, that means if you are extending a different class, then there is a chance of ambiguity of the variables. So this will confirm you are referring to the variable within this class, within this particular object instance, not referring to its superclass where it is extended from. This makes more sense once we discuss inheritance. Inheritance is basically extending a different class so that the functionality of the parent is merged into the child. That we will discuss when we are doing our object-oriented programming lesson. With this, I conclude this lesson. You may now move on. Thank you. Hey guys, welcome back. So package is primarily a way of organizing your class files or Java files. So if I want to put all of the Java files which are of similar functionality, I can organize them into a particular package. So let us group this file as Java fundamentals. In that case, all I have to do is go here and name it as Java fundamentals. So this file will be part of Java fundamentals package. Let us see what it's complaining. Okay, right now it's in the default package. Is saying if you want to make this file part of Java fundamentals, move it to that package. I will select that. Instantly you can see the Java fundamentals package is created right here, and underneath that I have top to bottom. I can do the same thing for welcome. Go ahead and do package Java fundamentals. move welcome to package Java fundamentals. So that is again moved into Java fundamentals package. So it will come in handy as number of files are increasing. So we can organize Java fundamentals, intermediate, advanced as such, but in real world it's more like Java. From the testing perspective, you can do a Java package of page objects, Java package of utilities, the common utilities, Java package of scenario definitions as such. It depends upon what are the various high level classifications you have in your project. Okay, that's the package. That's how you can use package to organize your class files. The next one is import. Java comes with a lot of utilities, so you don't have to write code from scratch for everything. You have to look into Java API and make sure if there is existing method that can help you with your problem. I will talk about how to use Java API in a separate session, but for now we will see how the import works. For example, a date function. Let us go back to our top to bottom. Here I want to print or access date, okay, date of the machine. Then I can write date D equals to new date semicolon. So see, it's complaining about date. Where is this date come from? If I mouse over on that, I can see import date from java.sql, import date from java.util. So as we advance in your course, you will know which one to call. Basically java.sql is for the SQL language format date, whereas java.util is Java format date. I will select the second one and the complaint goes away. If we scroll up, you will see a line of code is being added. Here we are importing java.util.date package, okay, or that class in this case, so that I can use the date functionality in my code. I don't have to write from scratch again date functionality, how it works and all that. I can simply import the existing java.util.date and straight away use it in my code. Let us see what are the methods available on the date. So it says date to string, okay, that works. Let us do a system out and see what it prints out. Okay, so making sure, again, this is for the starters, make sure every opening brace has a closing brace. Sometimes when you're trying to sys out, or if you're using multiple statements in a single line, that can get a little bit confusing. So every opening will have a corresponding closing. So here I'm running it run as Java application, and it prints out the date here. So Tuesday, November 27th. So it happened pretty much like a magic, right? So I did not do a whole lot of coding for this, because I simply used the date class that Java provided. To really use the date class, I need to import it. First of all, I need to know that it exists, right? That is where the experience or practice you will get that knowledge. For that, you can also refer to Java API. I will talk about that when we are discussing the APIs, available APIs in Java, but then you will know there is a function, there is a class exist for using the date, and we can simply import that. and straight away use it. Okay, that's the import keyword is for. Let us recap a little quick here. So we talked about package, which is for organizing the classes, similar classes into one package. And then import, we just saw importing the existing class and functionality into your Java class to use them. And public is the access modifier for the class. Public is basically it is accessible from anywhere within the Java program. And private has limitations. We can refer back to access modifiers lesson we discussed for public, private, protected. You can refer back to the access modifiers lesson. And the class is the keyword for declaring a class. And these two are class level variables. You can use them, you can access them within the methods, but method level variables cannot be accessed at a class level. This part I did not mention earlier. So the class level variables can be accessible within the methods, but method variable cannot be accessed at a class level. Remember that. Okay, so these are class level variables and these are method level. This is the method level variable and this is the method. And this is the method signature, whatever the parameters we are passing. And int is the return type, expecting an integer to be returned from this method. And yes, again, a method variable. This is the variable we declared inside the method. Hope you got that. If you have any questions, just add in our comment section. And this is where I conclude this lesson, and you can move on to the next one. Thank you. Hello, welcome back. In this lesson, we're going to talk about abstraction. In our list is the second principle of object-oriented programming. Previously, we have discussed about encapsulation. Encapsulation is a principle where you combine data and code into a single class. For example, employee class holds the activity like adding an employee. At the same time, the data, employee name, social security, salary, combined together into a single class. Whereas abstraction is a principle by which only essential details are exposed to the user. In the same example of an employee, I can expose add name, add salary, add SSN. But I don't want to expose certain methods which calculates bonus and commission for the employee, which is combined together into single component salary. That's what I want to expose to the user, but not the intricate details how the commission is calculated and how the bonus structure based upon the rank of the employee. Those details I don't want to expose to the user. So we will see an example where encapsulation in action. So if you look at here, encapsulation is data hiding, that is information hiding, while abstraction is detail hiding. So detail hiding means hiding the method details, whatever it is, how the method is written, or exposing the method itself to the caller. In Java, we can achieve abstraction by using either abstract classes or interfaces. Interfaces are 100% abstraction. So we will see the differences between an abstract class and an interface, which is a very popular interview question in a separate lesson. But for now, keep in mind, abstraction is achieved by using interfaces or abstract classes. We will see an example now. So let us start with creating a class which has an abstract method in it. So in this example, we create a class animal, and the animal class will have a method which is an abstract and non-abstract methods. When I say abstract method, it does not have any implementation for that method, and the method itself declared as abstract. Let's take a look at it. So here I'm creating a new class, and the class name is animal, and that class will have an abstract method. To make it more sense, let us add some methods which are relevant for any animal. Let us say it can be move, eat, sleep, make sound. Okay, these are the various methods. So let us start with move and eat. I will create two methods with that behavior. Since moving and eating is a common behavior for any animal, in most cases, not going too logically. So, and make sound is different for each animal. Each animal makes a different kind of sound. So that is the method I want to make it abstract. I will explain in a little bit why I have chosen that method to be abstract. So if a class has an abstract method, the class also should be an abstract, because there is no implementation for an abstract method within a class. So this should be an abstract class. So let us dive in a little bit. What does literally this abstract keyword means here? So what it means is, make sound is a method that will not be implemented within this class. Whichever class that is going to extend class animal will be implementing make sound method. So if you notice here, the method, how it was declared is, it doesn't have a curly braces like other methods which are non-abstract. Okay, so this might be confusing in the early stages, but it is pretty simple, because abstract is nothing but no implementation. Abstract, it's very vague, right? So abstract means no implementation, no clear picture at the time. So the reason I have chosen as a designer of this program, because the sound is different for each animal, whether it's a dog which barks and cat meows and donkey, whatever sound it makes. So the sound is different for each animal. I want to keep that abstract and leave the implementation, how it works, to that animal, the specific animal itself. So I have decided to declare make sound as an abstract method. It makes more sense once we start using this animal class in creating dog, cat, or donkey classes. We will see that in a little bit. So, and the two methods above, move and eat, those are implemented in this class itself. So if I put like sysout, you can do your detailed implementation, but I can do a sysout in this method and a sysout on this method. And abstract is a method that is not implemented here, so we don't have the curly braces. That's the syntax for the abstract methods. Now let us create a new class, which is a dog class, and finish. This is where one more new keyword I'm introducing it to you. We are jumping ahead of time. Extends is a keyword related to one more principle in object-oriented programming, which is inheritance. So we're going to see a little bit of inheritance while we are talking abstraction. So in Java, you can extend a different class into a subclass. So when I do dog extends animal, and that carries the methods that are already there in animal class. So move, eat methods are readily available now in dog because we are extending it, we are inheriting it. Just like child inherits certain properties, certain features of their parent, this is exactly the same. Dog is inheriting certain things from animal. For example, move and eat are inherited into dog, but not make sound, because make sound does not have an implementation in animal. So we are forced to implement make sound method in dog class. So let us see what is the complaint here. So when I mouse over, it says I need to add unimplemented methods. Let's click on that, and if you notice here, it is forcing us to implement make sound in dog class. So here you can implement the dog sound, sysout and print out woof woof as the dog sound. So here we have implemented an abstract method from parent animal in subclass dog. Similarly, if I create cat, I will implement that method in cat. Specific sound I will include in that cat class. Hope you're getting it. So the abstract by principle, it is hiding the implementation and let the subclasses implement the method for them. So it's a design principle basically. So in what situations you do that, it based upon, generally the parent classes will be abstract and forcing the subclasses to implement that. In the similar way, if you are defining a vehicle, right? And vehicle can have different kinds of subclasses: cars, trains, aeroplanes, trucks, and everything. But you want to force your developers to implement certain basic methods in each and every subclass, like move forward, move backward. As such common methods, you will write them as abstract in the parent class and force the implementers to implement them in their subclasses. Like I mentioned earlier, abstraction is achieved by interfaces and abstract classes. In this example, we have used an abstract class and an abstract method within the abstract class to demonstrate abstraction. So we will leave the interface to a different session, and let us conclude this lesson going back to see the definition one more time so that to consolidate everything. So here in encapsulation is, let us reiterate, because these are a little bit close to each other, encapsulation and abstraction. These two are two comparable principles, not similar, but we want to compare them to understand, because they deal with hiding certain information. In encapsulation, it is information hiding. We're creating an employee object and we're declaring member variables salary, name, and social security number as private member variables, and we are only exposing methods set name, set salary, set SSN, right? We are not exposing the real member variables. Those are private. whereas the methods we want to expose them to the user. So any kind of changes to the name, salary, or department, whatever, it should come through the methods, not through the member variables, because these are no longer accessible if you declare them as private for the caller. So that piece is basically information hiding, while as abstraction is dealing with implementation hiding. So we want to hide the implementation in the abstraction. So here we completely avoided the implementation by declaring it as abstract method. So the implementation will take place in the subclass where it extends the abstract class and implements in the subclass. The main advantage of using abstraction is you are leaving the implementation details to the respective class rather than implementing certain functionality in the parent class and again overriding them in the subclass, irrespective of whatever the implementation would be. So you don't want to repeat the code in the parent class and the child class. In that case, you can simply declare the method as an abstract and leave the implementation details to the subclass. There might be certain methods you want to implement them in the parent class and certain methods you don't want to implement them in the parent class. Those methods which you don't want to implement that can be declared as abstract, and abstract will force the subclass to implement it. So if I don't implement this class, if I delete this class and do Control S, if I mouse over that, this won't compile. It will complain either I have to make the dog class an abstract again or implement the unimplemented methods. So the first one, if I click on that, it will auto generate this piece of method for us, forcing us to implement that method. So the abstraction is a great concept for code maintainability and also delegating the implementation to the subclasses rather than writing in the parent class itself. With this, I will conclude this lesson. At a later point of time, we will discuss about interfaces, which is also a great way to achieve abstraction. Now you may move on to the next lesson. Thank you. Hello, welcome back. In this lesson, we will talk about object-oriented programming, which is a very important concept in Java. It consists of mainly 4 concepts, which are encapsulation, abstraction, inheritance, and polymorphism. We will discuss each one of them in detail and also implement in the code. So, object-oriented programming is a programming style which is associated with the concept of class, object, inheritance, encapsulation, abstraction, and polymorphism. In our previous lessons, we have seen class and object. Class is a blueprint where object is the instantiated version of the class. So if a blueprint has converted into an object, the object will have state and behavior. We talked about employee class, and instantiated the class as an object, providing with name, salary, and department information. Now that we know the difference between a class and an object, it makes it a little easier to understand the additional concepts. The biggest advantage of object-oriented programming is we can increase the flexibility and also maintainability of the programs. So if you want to expand the employee associated information, you can simply go into the employee class and add more member variables and methods relevant to the employee object. And maintainability wise, it's easy to maintain because it's more divided into objects and easy to maintain the objects then a procedural code. Let us start with encapsulation. Encapsulation is defined as wrapping up the data under a single unit. It is a mechanism that binds together code and the data it manipulates. Encapsulation is one of the relatively easier concepts to understand. Since we already have done class and an object, encapsulation is putting together relevant data into a single class. In our example, we have seen employee class has employee name, salary, and department. And we are providing access to the object only through methods, not through the member variables. Usually, encapsulation makes sure the object and its member variables are related. And member variables should be private, and the methods which provides access to the member variables are public. In this example, you can notice all of the member variables are declared as private, and the methods that expose the member variables are public. So we are encapsulating member variables and methods into a single Java class. All of the relevant information and code is stored in a single Java class, which is nothing but encapsulation. We are doing it by default in this case. With this, I conclude this lesson. In the next lesson, we will discuss about abstraction. Thank you. Hello, welcome back. In this lesson, we will discuss about inheritance, one of the core object-oriented principles. Inheritance is most commonly used principle if you want to extend the functionality and reuse the code without creating or repeating the code again and again. Inheritance also provides a greater convenience to manage the code. We will see these two main concepts in action in a little bit. And one important keyword that is associated with inheritance is extends. So if you are extending a certain functionality from a class to a subclass, we use the keyword extends. Let us take a look at some of the definitions here. So inheritance is a mechanism in Java by which one class is allowed to inherit the features which are instance variables and methods of some other class. The main terminology associated with inheritance is superclass, subclass, and extends keyword. A subclass is extended from a superclass. So if we take the hierarchy of animal and different kinds of animals underneath animal, like dog and cat, so dog extends animal, cat extends animal. Some of the basic functionality of, let us say in case of animals, behavior is defined in the superclass animal, which is common across different animals, and it will be extended into cat and dog so that you don't have to repeat that behavior again in the subclasses. So in here, let us see if animal is the superclass, right, which has this common functionality across all of the animals go into this animal class, and this animal class will be inherited by subclasses such as cat, dog, maybe camel. So different animals are subclassed from parent, which is animal class. So here let us see the terminology. So the animal class here, it's called the superclass, and the rest of them which are extended are called subclasses. So camel, dog, and cat are all the subclasses of animal. So as a designer of this software component, what I will think ahead of time is, let us put all of the behavior which is common across different animals into the animal superclass so that it can be extended by different animals. That behavior will come by default. So for example, every animal eats, sleeps, and moves. Without going too logical, basically these are the common things across different animals. So I can define them in the animal superclass. So these three methods, let us say eat, move, sleep, these are the three methods I want to define them in animal. When animal class is extended by cat, then these three methods will automatically come into cat class. So the syntax will be something like public class cat extends, this is the keyword, extends animal. So here all of these three methods, even though you don't have to literally write them in cat class, they are available by default. So this is the concept of inheritance. We are inheriting certain behavior from the parent class to the subclass cat by using the principle of inheritance. Hope you got the concept. Let us further enhance our learning by writing the code for exact the same example. We have kind of started on inheritance when we are talking about abstraction in the previous lesson. So we have created animal class and we have used extends so that to inherit the properties of animal into dog class. So by the principle of inheritance, this dog class should have the methods of animal by default. Let us see what are the methods in animal. So we have move and eat. Let us quickly create one more method, sleep. Now let us see if I create a dog object and call eat, sleep, move methods of dog class of the dog object, what methods are being called. If you notice here, we did not define any move, eat, sleep methods in dog class, but we will try to call those methods by creating an object of dog class so that we can see how inheritance works. For that, I will create a different class just to make a call, just to instantiate a dog object independently and treat that as a calling class, a class that calls, instantiate and calls the methods of dog. So let me quickly create a class by name calling main. We want to keep the main method in this calling main class. I created calling main and create a main method here. So just to differentiate the class and where it is being called from. Usually you will be creating, instantiating the objects in a different location. You won't try to create an object of your class within the class itself. For initial learning, we have created a main method within the class, but I'm trying to give you a direction of more how practically we do. So here, in this case, it's a main method, a simple main method, but the main thing is, here I want to create a dog object. I will call it as dog obj, new dog. That's how you create objects, right? And here dog obj dot eat move sleep. Control S to save it, and I will simply run it. Run as Java application, and in the output you can see eat, move, sleep are being printed. So if I go into the dog class, now I'm using control key and the mouse pointer so that it will take you to the definition of the dog class. So control key and pointing on the class, you can click on it. So it will take you to the dog class. It's an easy way to get to the dog class. So if you notice here, we did not implement any of these methods in dog class. Dog, eat, move, sleep are not being implemented in dog class, but they were implemented in animal class. So even though here in calling main, we are calling dog object methods eat, move, sleep, it is actually calling its superclass animal methods move, eat, sleep from the superclass. So that is how the inheritance works. So we have inherited the behavior of animal into the dog class. That is why we have this behavior available even if you create a dog object. Now the fun begins when you can override. Let us say you want to have your own move, if you want to have your own eat for a dog, if you want to have your own sleep for whatever reason, you can still do that. All you have to do is use the same method name and method signature to override what's in the parent class. Let us quickly do that. This is something we are going to learn in polymorphism, but just to clarify, in the spot I'm going to add this eat method, eat, to differentiate the text a little bit so that when sysout prints out, you should be able to know from where it is being printed. So dog eat in dog class, control S. Let us go back to our calling main and try to run and see which method will be called. Is it from the animal because it's a parent class, or will it going to call the eat method from the dog class itself because we are creating a dog object here? Right click, run as Java application. You see here eat in dog class is being called. Previously it's just eat, right, which is from the animal class. But now once we have implemented eat method in dog class, this overrid the eat method in animal class and it called the eat method from the dog itself. So we have printed eat in dog class. So you can override the functionality that has been inherited if you want to. Otherwise the default will be called. So you can see the advantage of inheritance. We don't have to rewrite the code again and again, and maintainability is also easy. So let us say you have subclass dog, cat, camel, crocodile, whatever, 10 different subclasses, right? But if you want to make a change for certain functionality, let us say how they sleep or how they move, whatever, you can simply change in the animal class. So all the subclasses will be affected. If that's your conscious decision. If you want to make a change across the board of animals, then you can simply change in animal, then it applies to all of the subclasses. So maintainability wise, it's easy because you're maintaining the core functionality within the animal class, and each individual subclasses are inheriting the code or the behavior into them. So the maintainability, it is very helpful, and at the same time reducing the repetition of the code. So with this, I will conclude the lesson about inheritance, and we will start on polymorphism in the next one. Thank you. Hello, welcome back. In this lesson, we will discuss about polymorphism, the fourth and last object-oriented principle in our series. Poly means many. Morph means transformation. So it loosely means many forms. The most practical usage of polymorphism principle is method overloading and overriding. We will see those two with examples in a little bit. Let us take a look at the definition of polymorphism. Polymorphism is the capability of a method to do different things based on the object that it is acting upon. In other words, polymorphism allows you to define one interface and have multiple implementations. So you can define a method in a parent class and a subclass, the exact same method, and you can make use of whichever method you want to at runtime by the concept of method overriding. So polymorphism gives the option to use the same method names in different ways. That is just one piece of polymorphism. Technically, a Java object is considered a polymorphic when it passes is a condition test. So what does it mean by that is, so for example, you have an interface, vegetarian. I know we haven't discussed interfaces, but assume that it's a kind of class, okay? So it's a class, a vegetarian, and another class, animal, and the deer class extends animal and vegetarian. So it has both of the methods of animal and vegetarian, right? For the deer class. So the deer class is considered to be a polymorphic because it is able to meet the is a rule for a polymorphic object, because a deer is a animal, a deer is a vegetarian, a deer is a deer, and a deer is an object. So every class in Java is an object. So is a object is also a condition it was able to meet. So if you ignore this, because we are comparing deer to deer, and every Java class by itself is will extend an object implicitly. So we can ignore these two for now, but technically speaking, if a deer is an animal and a deer is a vegetarian, so this is showing us polymorphic behavior. For now, treat this as a theory for now. The more practical usage of polymorphism comes when we discuss method overloading and overriding. So what is method overloading? If you declare a same method but different method signature within the same class, that is within the deer class, you declare a method eat and no parameters, and you declare eat method with parameters. Let us say you will pass what it is going to eat. In case of, deer, you can pass grass or leaves, whatever you want to. But there are two methods. One takes a parameter, one does not take a parameter. So that concept itself is called method overloading. Same method name within the same class, but different parameters. That's method overloading. And method overriding is same method name with parameters in the superclass and subclass that we have seen in our previous example of inheritance for eat method. We will see it again. So in that case, we are overriding superclass eat method with subclass eat method. When you call eat of your subclass, then your subclass eat method will be called. Get it? So overriding is literally we are taking away the method of the superclass and overriding with the method of subclass. Whereas overloading is same method name but different method signature within the same class. There is no concept here of a subclass and superclass. Within the deer class itself, you are using the same method signature. This makes more sense once we start writing some code. Let us do that. So in this example, in dog.java, we have a method eat, and we have a method eat again in superclass, right? When we ran this class before, run as Java application, eat in dog class is printed. So if you go back here into the dog class, eat in dog class, this is printed when we called eat of dog object. So this eat method is overriding the eat method of its superclass. That itself the polymorphic behavior, because you are controlling which method to call by overriding it. Suppose if we don't have this method here in dog class, I deleted the method and I'm saving this dog class and going back to calling main.java and running this main method so that to instantiate the dog class. So if I run this, you can notice only simply eat is printed, which is basically eat from animal.java. There is nothing overridden here. That is why the parent class eat is called. If I put back this eat method in dog class, save it and run it again, we will print the method from the dog class, which is the subclass. Now we are overriding the superclass eat method with the eat method in the subclass. So that's one of the practical uses of polymorphism. Since we have seen overriding, now let us see overloading. It's very easy to get this concept. What we have to do in overloading is create a different method with the same method name but different method signature. So here, string type of food, and here I will sys out something more reasonable so that we know what it is eating. Dog is eating and write down, sys out what type of food it is eating. So Control S, save that. Let us go back to calling main where we created our dog object. Here we are calling dog object dot eat, and again dog object dot eat. Now you can notice Eclipse is suggesting there is one more method with the eat. So in this case, I will type what type of food it is eating. Let us make it eat pedigree. Control S, right click, run as Java application. Dog in dog class is called with the first eat method, and the second one we are overloading. We are creating the same eat method but which takes a parameter. So dog is eating pedigree, whatever we passed. So if we go to that eat method, it takes the type of food, right? So here eat method and eat method with a different parameter. So this concept is called method overloading. We are overloading the same method but which takes different parameters. So polymorphic behavior, a different kind of behavior can be achieved if you can use these two concepts. One is overriding and overloading. For some reason I want to pass in a value for eating, so then I can declare a method with the same name but with the parameters that it can take, right? That is overloading. Overriding is I have this behavior in my parent class but I want slightly different behavior for my subclass. Eating is common across animals, but dogs, let us say, they chew and swallow. You want to implement a little different for a dog. So you can do that by overriding. So again, a different behavior can be achieved by using overriding. So these are two principles or concepts within the polymorphism: overloading and overriding. They have different names. Let us take a look at them so that you don't feel like, what is this new concept? So let us go back into our document here, and overloading and overriding are used to implement polymorphism. Polymorphism is classified into compile time polymorphism, or early binding, or static binding. You see all these kinds of different words that you can use for method overloading. And runtime polymorphism, late binding, or dynamic binding are used for overriding. So method overriding is one of the ways in which Java supports runtime polymorphism. Method overloading is one of the ways in which Java supports compile time polymorphism. So what it means is, when compile time and runtime are the keywords here, right? Compile time and runtime. Compile time, let us click on compile time. So compile time is basically overloading. If you go back here, by the time I will run and compile this and run, I already know that I will be calling which method based upon the method signature itself. So that is compile time. And runtime is basically until I instantiate the class, I don't know whether I'm calling the method in the subclass or superclass until I instantiate the object, which is at the runtime. So that is overriding. Overriding deals with the superclass and subclass, whereas overloading will happen within the same class itself. A different method signature within the same class will make it overloading, right? So the primary concept is overloading and overriding, and these are the different names for overloading and overriding in different contexts. So with that, I will conclude this lesson on polymorphism. Now you can move on to the next one. Thank you. Hello, welcome. In this lesson, we're going to talk about operators in Java. Primarily, we will see definition and examples of three kinds of operators: arithmetic operators, relational operators, and logical operators. Let us take a look at the definition and an example. An operator in Java is a special symbol performing specific operation on one or two or three operands and giving us a result back. In arithmetic operators, which is the first one here, the operator will help in mathematical calculation. So sum, subtraction, multiplication, and division. These are the four operations we can perform using arithmetic operators. In this example here, x plus y, a variable x is been added with variable y, and the operator we are using is a plus symbol. And relational operators primarily deal with comparison of one variable and another variable to the another variable. So x greater than y or x equal to y, as such operations you can perform using relational operators. Logical operators, which is also an important operator in coding, primarily works with evaluating two conditions to be true. So in case if you want to evaluate a condition to get a person who is within the age range of 19 years and 24 years, we will be doing if age greater than 18 and age less than 25. So which will exclude 18 and 25, we will get the age in between. So here we are using the logical operator, and these two ampersand symbols indicate AND operator. Similarly, there is an OR operator which is indicated by two pipe symbols. Let us see these operators in action by writing some simple code in Eclipse. Let us create a new class just for operators. So in Java Fundamentals package that we have created in the last class, I am doing a right click and selecting class, and I will name this class as operators demo and click finish. So the package is Java Fundamentals and the class name is operators demo. In here, let us create a main method. Main method is an entry point into the Java application. So if you want to run and see the results in the console, you need to have a main method. So let us create a main method. The shortcut for main method is just type in main and do Control spacebar, and you can select the main method from the drop down list box. So once we have the main method, let us start with arithmetic operation. Simply let us declare two variables, int x, which is equal to 5, and int y, which is equal to 10. This is so simple, we already did some examples before. So to hold the result, we will declare one more variable, which is z, and initiate with 0. And here we're going to add x and y and store it in z. And we performed an arithmetic operation using the plus symbol. And let us quickly do a relational operation. So in this case, what we will do is we will use the same variables down here and evaluate that. So if y greater than x, else. So here I'm performing relational operation by comparing y to x. So if y is greater than x, simply we want to print out y is larger number. If y is not larger, obviously x is larger number. So we will talk about logic building and conditional statements and conditional statements and loops. So we will cover the if statements and else statements, but just to demonstrate a relational operator, how the comparison happens, we want to use this if statement here. With this, let us run and check out what we are getting in the console. So in the console, we are printing y is larger number. Obviously y is 10 and it is larger number. What if y is 3? I will save that and I will do run as x is larger number. So we are using a relational operator here to compare two numbers. And earlier we have used arithmetic operator to get the sum of two numbers. Let us add this out here also and simply say the value of z is z. And finally, let us do a logical operator. Logical operation. In this case, what I want to do is to demonstrate logical operation, we will be using AND or OR. So if z, there are three variables so far, right? So if z is greater than x and z greater than y, just print out z is the greatest number of 3. So here the key is we are using AND operator, which means both of the conditions should be true to get into this situation. So it should be z should be greater than x and z should be greater than y, then only we will get into this condition here. So AND evaluates for two true conditions, whereas OR evaluates for one true condition. So if I do the same thing with OR operator, so we will get into this condition, the statement even only one of them is true. If the z is greater than x, yes, it happily enters into this condition. Or if z is greater than y, it will enter into this condition. If both of them are false, then only it won't execute this line of code. One condition matching, this will be moving forward as a true condition and we are executing line number 33. Whereas in AND operator, you have to have both of them as a true condition. This should be satisfied and this should be satisfied. So let us take a spin here. Let us run the code and we can see the value of the z is 8 from arithmetic operation and x is larger number. This is from relational operation where we compared the values together here, y greater than x, then this one holds true. If y greater than x is not true, then we will get into this part of the statement, which is what it is printed here. And the third one is logical operation, where we did z greater than x, and in both of the conditions we're satisfied because in this case also both of them are true. Not necessarily it has to be true. For example, let us switch places. Y is definitely lesser than z, but still, since one condition is satisfied, we will print the line number 33 here again, even though this condition is not satisfied, because y is smaller than z. Let us run this. We can notice that the statement is again printed because it is only evaluating for one true condition when you are using or as your logical operator. Okay, so the plan is you will be learning bits and pieces of the syntax. We have seen variables, you have seen the whole dissection of the class, from package to import to the class method and method level variables. So we will try to connect all of the dots together in one lesson. Okay, so now we will be learning scattered pieces of Java. Today in this class we discussed about operators, and we have seen operators in action. And the future class we will be talking about programming logic development. In that lesson we will discuss about conditional statements like if statement, loops, for loop, while loop as such. And I will also be uploading this code and provide you with the link so you can download into your local machine and run them locally. And more importantly, I want you to create your own class file, make some tweaks to it and run it. Okay, this is where I end this lesson. Thank you. Hello, welcome back. In this lesson, we're going to talk about conditional statements, loops, and logic development. Conditional statements and loops are core of any programming language. If you learn it once, you can apply it to any programming language. If you want to build logic, these are two necessary ingredients. Now let us take a look at what is a conditional statement. A conditional statement performs different computations or actions depending on whether a programmer specified Boolean condition evaluates to true or false. So in this case of an if statement, whatever the expression is there, if it is evaluated for true, then this particular statement will get executed. Else it will move on to the next condition, which would be else if it is true, this will be executed. Else it will move on to the default one. Irrespective of verifying the Boolean, it will simply execute the last one if it doesn't have a if associated with it. So here is the key. If this condition is true, this will get evaluated and rest of the else will be ignored. Only the true condition, whenever it meets the true condition, that is what it is executed, and rest of the following will be ignored. Let us take a look in Eclipse how to use a conditional statement. In Eclipse, I'm going to create a new class by name Logic. We will include both conditional statements and loops into that class. Let me copy the definition here so that it will be there in the source code always. Once you copy any kind of text or comments, we need to put them in block comment or comment by each line. So the block comment works with /* star and closed with star and /. So which means the compiler will ignore whatever the text is there in between these two points. So now let us think about a particular goal and write the conditional statements. Using conditional statement, we will try to, let us say, figure out a person is a teenager or an adult or somebody else using the conditional statements. So the age will be provided to us, and we need to use conditional statements to print out whether that age belongs to the range of a teenager or an adult. Let us declare a variable by name person age. And for now, let us put it as 0. Now let us develop a conditional statement to verify two things. One is verify if it is a teenager or an adult. So let us try doing if we need that variable person age is greater than 20, we want to print it as adult. So let us put this code in a method, a main method, which will be easy to run. So main control spacebar, it is a shortcut we can use to create main method easily. A curly brace goes after this statement. And you can use Control-Shift format to really format the code properly. It gets a little bit cleaned up, especially with the indentation, how far it is from the left, and it will appear more cleaner. So now that we verified for an adult, let us figure out if that age belongs to a teenager age group. Else if person age greater than 12 and person age less than 20, we want to print out as a teenager. So person is teenager. Let's put an else statement. You don't have to, but if you have a default scenario you want to print out, you can use else statement. Age unknown. One more Control-Shift-F key that formats the code. And now let us run the code as it is. We have initialized the person age as 0 in this case. Let us run this code. Run as Java application. And the console came up here. Age unknown. Because since we assigned the age as 0, it does not fit into this condition and also this condition. 0 is not greater than 20 and 0 is not greater than 12 and 0 is less than 20, but this is an AND operator. You need to meet both of the conditions to be true to execute this. If you use OR operator, this would have definitely executed. But here we want to make sure for finding out the teenager, they need to be greater than 12 and less than 20. and less than 20. So we use AND operator here. Now let us change this age to, let us say, 21. 21, person age 21 greater than 20. So this gets executed, and for whatever reason, if this condition is also true, it won't get there, like I was telling before. Once a true condition is evaluated, it won't go into any of the next conditions. So in this case, the first one will be executed because 21 is greater than 20. Let us run as Java application, and you can see person is adult. Now let us try to meet a condition for a teenager. I would say, let's say 14, right? And save the code, right click, run as Java application, and person is teenager. Let us give an edge case like 19-year-old and run as Java application, person is teenager. In conditional statements, we typically use relational operators and logical operators. So to condition to be verified, typically we try to check whether it is equal to or greater than or true or false. True or false is done by using Boolean, which is like checking if it is true or false. Just like integer person age, it can also be a Boolean male female, and based on that you can also evaluate the condition. With this, I conclude conditional statements. We will see loops in the next lesson. Thank you. Loops are a great way to repeat the same task again and again. So the maximum utilization of any computer is to do the repetitive tasks. Humans are not great in doing the same thing again and again. We know that. And computers are widely used for automating the process of repetitive tasks. That's how we use automated testing to test the web application again and again using the code, rather than a person sitting the same functionality again and again. So loops help with repeating the execution of the particular set of code for n number of times. You can specify how many times, and the repeated execution allows you to do the code. Primarily there are two types of loops. One is for loop and another one is while loop. Let us take a look at for loop in Eclipse. For the sake of clarity, I will create a new class. I will name it as logic loops. So go into the package, click on that, and class, I will name it as logic loops. The first thing you can do is creating a main method. That's how you can run the program and test it. And in here, I will write a for loop to start with. This is how the syntax goes. A for loop will have for and int I equals to 0, semicolon, I less than some integer value. For now, I will keep it as 10, semicolon, I plus plus, open curly brace, close curly brace, and within here you can put your code. For now, I will put a sysort statement which will simply print out the I value. So I will add a comment, a text string, the value of I is, and concatenate the I value here. Save it, run it first, and explain to you. We can see the values are printed out here. So it executed starting with the 0 and went up to 9. So what we are doing here is a couple of things. In this particular statement here in the for loop, we are initializing a value, declaring a variable and initializing it to a value, and we are providing a condition here itself. Do this loop until I is less than 10, and then we are incrementing it. We have to increment it here so that every time it executes the first time, the I value gets incremented, so that we will keep track of how many times we looped. And here, once we have this loop established, this particular statement will execute 10 times, because it's starting with 0 and going up to 9, because 10 is not less than 10. In that case, if you want to execute for 10 times, with including 0, it will be 11 times. You can do I less than or equal to 10. If you run in this case, it will run up to 10. So learning about conditional statements and loops is the first step, getting familiar with the syntax, and second thing is implementing, using it for certain kind of logic. So let us make this loop more interesting. We will combine age identification so that the conditional statements will be part of this for loop. We will use our previous code so that we can check whether a person is an adult or a teenager. Let us do that. So I will copy the if condition code we have, which checks for teenager and adult, from logic.java class. And here I will take all of these statements. I'm not copying the age. I will tell you why. That's where we are going to use for loop. And I will paste the code here. And let us say replace I value as person age. It doesn't matter. You can declare it as an I or any particular meaningful name. That should be fine. So I will replace that as person age so that we can use that value in our if statement. If you see here what I did, basically I copied the if statements from the logic for conditional statements, and then I have kept it inside the for loop. Okay, so input is not hard coded as we did before. In logic.java, we have hard coded the value to 19, or we need to keep on changing it to really verify the condition. So here I'm trying to take the loop as an advantage and let the loop run for however many times I want to and evaluate the conditions. So since if you run 10 times, it won't even meet any of our conditions, right? 10, it won't get in here. 10 is not greater than 20, and 10 is not greater than 12, 10 is not greater, 10 is less than 20, but it's an AND operator, so both conditions to meet, so it won't fit in here. Only it will get in here because it's 10. So all the time it will print out age unknown, age unknown, age unknown. So let me remove this so that we will have a little clear output. I'll try to run as Java application, but we are using age 10 only as the limit. So now if I want to get into these two statements, what I have to do is I have to go at least up to 20, right? And so that it will print teenager couple of times because it meets the condition of 13, 14, 15, 16, 17, 18 and 19 for a teenager, that 5 times, and then one condition of an adult, which is 20. So let us run and test that. Run as Java application. See, bunch of age unknowns, and person is a teenager. We have it for a couple of times here, and it came back to age unknown. Let us see what's going on. Yes, I see here person age greater than 20 is what our condition is. So it went into unknown. So if I have something like greater than or equal to 20, then this would have resulted in our console. Let me Control S and right click, run as Java application. Now we see person is adult. Because I changed it to greater than or equal to 20, we are looping only till 20, so we got only one adult scenario. Okay, one more time, let us increment this to loop to 25 so that we will get a bunch of adult scenarios also. I will reduce the starting point. You can also do that. It not necessarily it should be 0 all the time. So I will increase it probably to 10 so that we will have a bunch of unknowns, teenager and adult scenarios. Control S, right click, run as Java application. So we have a couple of unknowns and teenagers and adults. You get it? Isn't that fun? If you are new, I want you to spend good amount of time in between these two logic development statements, the for loops, the loops, and conditional statements. So look out for an assignment on this. With this, I will end this lesson. You may now move on to the next one. Thank you. Hello, welcome back. In this lesson, we will discuss about Java collections. Java collections are a concept of holding similar information into a single collection object. So what are collections and why we need collection? So collection is a way of holding references to collection of objects. Let us say I created an employee object. This employee object is specific to John. And I created one more object for Joe, and one more object for Smita, one more object for Amanda. So we have 4 different objects. I want to hold them together as a collection. Then I need a collection object to really hold different employee objects, right? That's the easy way to hold together all of the similar objects into a single variable. So in this lesson, we will discuss about 2 different types of collections. One is array list and another one is hash map. There are a lot of different collections available from Java out of the box. These 2 collections are most frequently used ones. I will also provide information how to use other kind of collections so that you can go through their API documentation and use them as required. For array list and hash map, we will try to use it, implement it in our Java coding. So here is a little formal definition. A collection is a group of individual objects represented as a single unit. Java provides collection framework which defines several classes and interfaces to represent a group of objects as a single unit, of which hash map, array list, hash table, hash set, queues are few of them. So at a very high level, java.util.collection and map interface, which is java.util.map interface, are the 2 main root level interfaces of Java collection classes. Let us take a look at the API documentation. So in the API documentation for collection, interface collection, these are all the implemented classes under the collection package. So of which ArrayList is one of them. So similarly, we have different kinds of classes which are implemented as part of the collection interface. So you can go through all of these, but as a starter, it is not really required for you to go through all of these classes. So if you know ArrayList and maybe hash set, you are pretty good shape for getting started. In our lesson, we will take a look at ArrayList, and rest of them you can look on demand as required. Like I said, they are not frequently used ones on a daily basis. Let us take a look at the map collection also. So for the map interface, these are all the implemented classes, which means these are all based out of map interface. So under map interface, the popular ones are hash map and hash table. And in our lesson, we are going to look at hash map. Hash map or anything under this collection primarily operates on key value pairs. That means whatever you're storing, it has a key and a value. For example, employee ID and employee name. Or if it is a flight number and flight name. So a key value pair is always associated. Not necessarily a number and a string. It can be both numbers or it can be both strings, but it always exists in the form of a pair. So why we need collections? We already briefly discussed it is a way of storing multiple objects into a single collection object. So if I want employees, all of my employee objects, I want to store them into a single collection, I can store it into a single collection, let us say an ArrayList collection. Basically, it reduces the programming effort. You don't have to write your own classes to handle multiple objects. And it also helps with sorting. It also helps with storing and retrieving from the collection. All of this has been already written as part of the core Java. So you don't have to reinvent the wheel. That is the number one advantage of having you to use collections. And depending on your usage, it increases the programming, the execution speed and quality. In the sense, for some situations you want to retrieve some value faster. In some other cases, you want to store the values in an orderly fashion. Depending upon your necessity, you will choose your collection. So let us say you want to send 5 documents from person A to person B. So do you want to send one document at a time to person A to B, or do you want to include all of these documents into one single envelope and send it to person B? We prefer to include all of them together into a single envelope and send it to person B. This envelope is nothing but a collection. So I have multiple sets of information and I want to send it across. In that case, I can use a collection to pack them together into one single object and move it around, or simply store into it and retrieve from it as required. For practical purposes, we will use our employee class and create multiple employee objects out of this employee class, and we will store it into a collection which is ArrayList. Now let us dive into the code and create a collection of ArrayList to store multiple employee objects. In one of our previous lessons, we have already created an employee class. So we will use employee c.java, this particular class, which is an employee class which has name information, department, and salary information in this employee class. We named it employee C because this particular class is using a constructor. Refresh your memory on constructors. Constructors allow us to create an object by passing the required parameters. The constructors are the first method to be called when we are creating an object of a class. So constructors will be called first when you are creating a new object out of a class. So we will use this employee C class to create multiple employee objects and store them into one collection object, which is an array list of type. So let me create a new class to create multiple employee objects. So in Java Fundamentals package, I'll create a new class and name it as array list collection. And in here, we will create employee objects. First of all, I need a method. You cannot simply start writing code without a method. So we will add a main method in this class. And within the main method, we will create, for now, employee 1, emp1, emp2, and emp3. So here we have a suggestion to add arguments so that we can call the constructor and create the object directly. I don't have to go through .set name, .set department, .set salary. You don't have to call those methods individually, because let me show you, then you can understand a little better. So I can create this object first and try setting the name and salary and department. That's one way. The other way is simply call the constructor by passing all of the 3 parameters to it so that it creates the object by setting those values. I don't have to individually call each one of them, which is taken care within the constructor already, right? So let us go back to our array list collection and accept the recommendation to add arguments, right? And the first one is a string. When I mouse over, we can notice the first one is a string, second one is a string, and third one is a salary. So name, department, and salary. So let us say the name John and department IT and salary, which is an integer, so 4,000. And again, we'll do the same thing for rest of the objects. So Kiran, finance, and salary 5,000. And then the third employee, Amanda, marketing 7,000. So here is a complaint again. We are using the same variable name within the same scope twice. So employee 3. Now we have created 3 employees, right? EMP1, EMP2, and EMP3. And just for the purpose of you refreshing your memory, I will try to do something like EMP1 dot get name. I will do the same thing for rest of the 2 employee objects, so that we will try to print out the values we have given back to the output. Okay, so I will add a system out here, sorry, and we'll do the same thing for rest of them. Right, let us quickly run just to assert these values are assigned. So run as Java application. I did not save, so save and run and click OK. Now you can see the output here. I'm in constructor. That's the statement from the constructor of the employee C class. And again, these are the 3 values we have assigned for these 3 employee objects, right? So let us take a quick look at the constructor. What it's doing, it is simply printing out I'm in the constructor of employee C. So we have assigned those values to the 3 employee objects. Now let us do the new collection, which is an array list we are going to demonstrate here. So if I want to pass these 3 values to some other method, how can I do right now? I have to pass individually one by one EMP1, EMP2, and EMP3 as 3 different calls, right? Or I can pack them together into one single collection, which is an array list, and add them to that array list and pass that single array list to a different method, right? And I can also retrieve them as I require. So let us declare an array list and add these employee objects to array list. So in here, I will create an array list of employees. So the syntax would be like array list, what we are trying to create, and a name for it. Let us call it list of employees, and it's a new array list. And let's mouse over that and see. So it is recommending to import array list, which is part of java.util package. Yes, obviously we want it. If you want to use the array list, I will click on the first one to import array list. Once I click on that, java.util.arraylist is imported. So Java already providing us with this collection package in which array list is one of the classes. And here syntactically we have to give this array list what type of object you're going to store in this array list. Even if you don't give this employee C in this angular brackets, it's fine, but it is highly recommended to use what type of objects you're going to store into the array list. Logically and practically, it makes more sense to store similar type of objects into an array list. You don't want to store objects of employees and again objects of departments or objects of salary scales. We don't want to mix up different kinds of objects into a single list. So this, if you provide this employee C as a type of array list you're building, will enforce you are only storing the objects of type employee C. Okay. Now we have created this array list. Let us start adding employee objects to this list. Dot add of type employee C, which would be emp1 is one object, I will copy and paste and replace the name of the object. So now we have all of these three objects as part of list of employees array list. So you would ask, where is the proof it's stored, right? Let us try to print out by iterating through the list. The keyword iterating. Iterating is going through the list. We will see how to iterate through the list in the next lesson. Thank you. So how to go through the list and print out, we will be seeing in a moment. We can iterate using the iterator interface, or you can use enhanced for loop. Let us try with a little bit complex looking, but it's very simple. Start with the iterator one. So to use iterator one, we have to get an iterator from the list. So which would be like, iterator kind of works like a cursor transversing from one element of an array list to the next one. So if you stack a couple of things, it will go through the list of things one at a time. So to use an iterator, you need to declare an iterator, which is for employee C type. We need to grab this list of employees, which is the array list dot iterator. So if you need documentation, right there, iterator returns an iterator over the elements in this list in proper sequence. So it is a cursor is returned to us so that we can go through the list of the elements in a sequence. And let's select that, semicolon, and let's mouse over and see what's the complaint. Here I need to import the iterator, so java.util iterator. If you notice here, you can see iterator javax swing.text.html. You need to be cognizant about it. You need to know that we are importing the right class, right? So java.util will consist of all of these utilities of collections. So we need to be aware of that. Javax swing is more of an UI related iterator. So that's not relevant to us. So don't simply select the first one. Pay attention to which particular package it is coming from. So in this case, we are using collections. So I will select the second one, which is java.util. And so here, what else going on? Okay, we are getting iterator of employee C, but we did not give any name for this iterator. I will just say it IT, or maybe iterator. And now we can use iterator to go through each one of the employee list. So I will use a while loop and say while iterator dot has next. So has next is what we want to use because that's the boolean. If it has anything, if it has employees, then only move forward with this particular while loop, right? So let us say if it says, if it is a true condition, let us say iterator says has next. Okay, it has employee 1. Then try to go into the curly braces, do whatever you want to do. So in our case, what we will do is we will simply sys out here and let us say just print out the object here. So iterator dot next, which is obviously an employee C type of object, right? And let us say get name and repeat it as long as you have some kind of object in this list. So let us run this and I will also recommend as a starter, if you want you can print out what this is returning. Obviously, it is returning a Boolean. That means true or false kind of value back. Because if the list has more values, then do this. If list is returning like there are no more values, that means it's already reached employee 3, then this will return false and this won't be executed. And it will go to the next line of code if next line of code is present, right? So for now, let us run this. What we are going to demonstrate here is basically we developed an iterator, which is a cursor to go through individual objects inside the list, employee 1, employee 2, employee 3, one at a time, and try to print the values back to the screen, so that we will confirm that this array list is storing employees and we were able to retrieve their values using iterator, right? Control S, right click, run as. If we run into any problem, we will fix it, but let's run it. So here it printed out back John, Kiran, Amanda, all 3 employees back here. So if you want to be a little bit more precise, like to differentiate the one from the loop, we will do inside list iterator space plus sign to concatenate that value, to add that value, and let us run it one more time. Run as Java application, inside list iterator, John, Kiran, Amanda. So we were able to store the employee objects into array list, right? And we used iterator to retrieve those values of objects back and able to print it onto the screen. So here, typically for the starters, they will get confused about iterator, right? So you should not be confused. It is simply a syntax, number 1. And number 2, what does it mean is, it is basically a cursor. So if you stack books on a table, 1, 2, 3, 4, 5, 6, right? And you use a pencil to count them from bottom, right? So you will start with the bottom book, 1, 2, 3, 4, right? So the pencil, which is pointing to individual book on the table, is an iterator. So we need a kind of cursor to move through the collection of the books. So iterator is going to help us to go through the collection of books on the table. For enhanced for loop, it's about like for employee C emp colon our list, open curly braces, close braces, and simply use that variable and the iterator will go away. We don't even need that. emp inside enhanced for loop. Is that nice and simple? So all we're saying is, these are the list of employees. Get me one employee at a time, which is of type employee C. Get individual employees out of this. That's the for loop syntax, as simple as that. So let us run this, run as Java application, and you can see at the bottom, inside enhanced for loop, John, Kiran, Amanda. Similar to the way we used iterator, but this is much cleaner and simpler. So there is no concept of iterator here. You can still do that using enhanced for loop by using the same list. So for retrieval, you will have typically using iterator option or enhanced for loop option, and each of these ways are fine. So with this, I will conclude the array list lesson. We will do a separate lesson for hash map. Now you may move on to the next lesson, or practice this one and get it to working and then move on to the next lesson. Thank you. Hello, welcome back. In this lesson, we will continue discussing collections. Particularly, in this lesson, we will talk about hash map. Hash map represents a key value pair. It's a form of collection derived from map interface, which stores key value pairs. For example, if I want to store employee ID and employee name together, I can store it in a hash map. If I have ID, I can simply retrieve the name of the employee from the hash map. So with the definition, hash map is a map-based collection that is used for storing key value pairs. And here is the syntax. Hash map is basically a new hash map of type integer and string. So these data types can be of any type. For now, in this example right there, we are using a data type of integer as a key and string data type as value. So let us dive into Eclipse and create a brand new hash map and go from there. So in our previous lesson, we have created an array list, and the array list, we have iterated through the array list using iterator and also using enhanced for loop, right? These are the two ways you can iterate. Iterate means go through the list. So similarly, we will do for hash map also. I'll create a new class by name hash map collection. And I will also create a main method inside that. So within this main method, we will use our syntax to create the hash map. And I will name this map as, let us say, I'm going to store employee ID and employee name. So employee ID name map. Though it is lengthy, it is relevant to whatever operation we are doing here. And if I mouse over here, it suggests me to import the hash map. We will go ahead and do that. And once that is done, I can simply use this hash map and keep adding key value pairs. So dot, you will get a whole bunch of methods that are available on hash. So now it is a good time to check the API for the hash map. Let us associate the specified value with the specified key. So put is like adding a key value pair. I will start with that and then we will check the API. And let's say employee ID 100 and the name of the employee is John Doe. Similarly, I can keep on adding any number of employees I want to. Make slight changes to the name here. And also the IDs. Control S. So we created an employee ID name map with these values. Now let us take a look at the API for hash map. So in the API for this hash map, we can notice the methods available here in the method summary: clear, clone, compute. There are various kinds of methods here, but my interest, at least as of now, is what is put does. Associate the specified value with the specified key in the map. That is good. What about removing? So this is the way to remove it. One important thing is empty. If you want to check if the hash map is empty or if it has some values, there's a straightforward method available. And then for iterating, there's a little bit of extra step we need to take when you are dealing with hash map. That is, you need to use an entry set. Returns a set view of the mappings contained in this map. So let us say this bunch of key value pairs, right? To iterate through that, first I need to get the set of them, like all of those key value pairs. And once I get the set of them, I can go through each individual entry into the hash map. We will see that in the code in a little bit. Let us go back to the Eclipse and try to print out the values we just entered into the hash map. So to print out, we need an iterator, like a cursor that goes through each individual entry in the hash map. So there are two steps involved. First, I need to get the entry set, and once I get the entry set, then I will get each individual entry from the iterator. Check out the syntax. It's basically first and foremost iterator, which is like a cursor. I will name it as ITE for now, and the iterator can be, it's an iterator on the set of the values, so which would be hashmap dot entry set, which is a set of values, and from the set of the values I want to get an iterator, so iterator on this set. So now iterator is a pointer on this entry set. Import java.util iterator, and then once we have the set, I need to get individual entry. So this is a set, and then within the set I want to get an individual entry, so which would be of type map.entry because it's a hash map, and here we are using integer and a string as a key value pair. So I will just name it as key value, and we need to get this from iterator has next. Let us see what the complaint is. Type mismatch cannot convert boolean to map. So this value is trying to, has next is returning us a boolean if there is any next item available or not. So this is not the method we want to use. Has next is like checking if there are any additional entries. So we want to use dot next, which kind of gives us the next entry in the list. Now what? Let us see. Add cast, type mismatch, convert object to object. So this is returning an object, but this is of a type which has an entry of type integer and string. So we need to cast it so that it is enforcing the rule, like that entry should be a key value pair of type integer and string. So now finally it's the time to print out, but before straight away printing, I want to ensure if there are any elements or not on this iterator. So this is where we need to use has next. So if it has any elements, then only do this process, and this key value dot get key plus key value dot get value semicolon. Let's throw this out in a sysout statement so that we can print it to the screen. Control S. Once I run it, I will go through it one more time. Right click, run as Java application, and we can see these values are printed back to us. So here it might be a little bit cumbersome if you are doing it for the first time, but what we are trying to do is, in case of hash map, it works a little different, because here we're trying to get key value pairs. So first we need to get an iterator, a cursor out of the entry set. That means the total number of entries in this hash map. And then once we have the iterator, then using that iterator we are just going through them and getting the next one, and the next one which will be an entry type, which will be one individual entry. So this is where we are getting the full set, and then within the full set I'm getting individual entries, and individual entry of key value I can get the key, get the value. You get it? So there are two steps involved. Let me compare it to the array list so that it gives you an idea, where array list does not have this extra step because it's not a key value, it's directly one object stored at a time. So in this array list example, we have created an array list of type employee, and we kept on adding a list of employee type objects to it. When we are doing the iterator, we're straight away getting that object, individual object, employee 1, employee 2, employee 3, and trying to print out employee 1 dot get name, employee 2 dot get name, employee 3 dot get name. So we're straight away printing that. In case of hash map, it is a key value pairs. First we need to get the set, entry set, and then we have to go through individual element of those sets. So here we got the set, and from the set we got the iterator to the set, and we are going through the list of this entry set and checking out if it has next value, then try to print out, get that next value, and from that next value, whatever it is, it's a key value pair, it's not one value. So that is why we need to do the entry dot get key, entry dot get value. Okay, so these are the two-step process in case of hash map. But once you get the syntax correct, it's pretty much the same process. Get the iterator and then iterate through individual entries and get the, from each individual entry, get the key, get the value. Okay, so that's a hash map. Let us try to do this using enhanced for loop. So enhanced for loop is basically for each entry, okay, each entry in the entry set. That is the goal. And for the entry, get key, get value. Okay, I'm just giving you a pseudocode before writing the actual code. So for that, let us say entry from the entry set. For the entry, it would be of type map.entry, integer and string. That's just the declaration, and give it a name, like simply this is the name I'm giving entry. It can be anything. So for the entry set, the way we get the entry set is from the hash map dot set. Now you got it. This enhanced for loop is more clear because there is no iterator involved in this case. So here for each entry out of the entry set, now this is the one which contains the key value pairs. So I will do entry dot get key plus entry dot get value, and here I will add the sysout, control space bar, right click, run as Java application. We can see an extra set of map entries here through enhanced for loop. So we have seen both of those approaches. Now let me include a PDF document right after this lesson so that you will have the comparison between the array list and hash map, and so that you can compare how they differ and when to use which one. Okay, so let me go back and see the advantages one more time. So the main advantages of collections in general, not like one collection but any kind of collection, reduces the programming effort. Programmer does not have to worry about the design of a collection and you can better focus on how to use it. This will be part of the Java itself, so it comes with a lot of methods you can use by default. That's the biggest advantage. And code quality is better because this has been tested and included into part of Java framework, and you will have reduced effort in maintenance again because this is well tested collections. So these are the various reasons you will use collections, and the concept of holding multiple sets of data into single variable, whether it's an array list or a hash map or a hash table or linked lists. Any one of these collections is very useful in actual programming. And from test automation developer point of view, I highly recommend focusing on these two first, array list and hash map, and then you can research on the other types of collections. With this, I will conclude this lesson. You may now move on. Thank you. Hey guys, welcome back. In this lesson, we're going to see how to create a file from scratch, write values into it, read those values back into the program. In Java, by using the built-in classes, this process is relatively easier. Let us step back a moment. Why we need to create a file and when we will be using it. So in scenarios where you want to store values temporarily, where do you store? Let us say you're running a test and you want to use the output of the test 1 as input to the test 2. In those cases, you want to store those values, whatever the output of test 1, into a file and use those values in test 2 to continue with the testing. Also, if you want to store the values out of the test results, then also it's a good advantage of using a file. I ran this test and I want to print out the output of it into a file, then I will be using the file again. So for reporting purposes, it won't be a fancy report like a TestNG would create, but still for debugging purposes, you want to know the test results customized by you. In that case, you want to write to your file, right? Like simply making a notes. So in Java, we will use Java file IO, which is java.io package, contains nearly every class you might ever need to perform input and output operations in Java. All these streams represent an input source and an output destination. A stream can be defined as a sequence of data. There are two kinds of streams. Input stream. The input stream is used to read data from source. Output stream is used to write data to a destination. In this example, we will write text to a file and read the text from the file. So I will create a new Java class by name fileio.java. To keep the code clean, what we will do is we will write two different methods. One is write method, another one is read method. And then from this main method, we will create an object fileio and call these methods so that this write and read methods are independent of each other. Let us start with write method. So to write to a file, we will use Java built-in classes. Those are a file class, file writer class, and buffered writer class. So let us start with creating a new file by name testfile.txt. So in these three statements, the first one is basically a file object, which is a convenience class for creating file and paths. And file writer is actually for reading the characters from the file or writing the characters into the file. And buffered writer is to provide efficient reading and writing into a file. We can totally skip this buffered writer. You can still use directly file and file writer, but when you are doing a lot of IO operations, that is input output operations, using buffered writer is more efficient because internally it buffers the characters that you are writing and pass them into the file in a transactional basis, all of them together after it has accumulated certain number of characters. So it's more of a performance thing, but still a lot of the methods that were available in buffered writer or simply file writer, they are common to each other. For now, let us take the efficient approach, right? So I will be using buffered writer and comment that. And once we do bw buffered writer dot, you will get all of the methods that were available on that class. So we can do bw.write, and you can also do bw.newline. That means it goes into the next line. It's like a carriage written, right? So let us start with bw.write hello, and then bw.newline bw.write here I missed the quotes. Let us insert the quotes around hello. So if we run this particular piece of code, which is creating a file and instantiating a buffered writer to write into that file, we will be creating a new file by name testfile.txt. Let us run this code. Actually, as a matter of fact, we cannot run this code because we don't have anything in the main. It will run, but nothing will happen. So because nothing is present in the main method, right? So we need to instantiate this object and call write method. For that, I will be doing in the main method file IO and call this write method. So here in the same class, I have instantiated this class and the object is FIO, and I'm calling the method of this class, which is write. So now we can run and see how it goes. Right click, run as Java application. It ran, but we did not see any kind of message because we did not do any sysout statements. Let us check if it has created a file. So we can see here testfile.txt is created. We need to go into the project level and refresh it, then only you will see this newly created file. I will double click on it. We're supposed to see this text inside of it. Let us see. We don't see any text. So let us troubleshoot what happened. Buffered writer, write, new line, again write dot. It looks good. It seems like we did not close the buffered writer. Without closing it, it will not complete the writing process. So let us close it. And rerun it. Right click, run as Java application. To make sure the file is updated, I will refresh it and go into testfile.txt. Now we can see hello test automation. So once you open the buffered writer, we are supposed to close the buffered writer. Then only it confirms we are done with writing to that file. That's why when we did it in the very first time, it did not write to the file. So similarly, let us write one more method for reading the file. Whatever we have written to the file, we want to read that. So let us create one more method by name read. So here the process is pretty similar. Instead of writers, we will be using readers. Here we need to add the try catch block. Whenever we are doing file IO operations, we have to use some kind of exception handling. We will surround this line of code with try catch block. We need to move this line of code into the try block. Now we will be reading from this buffered reader. So br dot read line, and this string should go somewhere. So we will pass it to a variable. We can see a complaint here. Let's see what it is. So again, then there is IO exception. It is throwing. We need to again use try catch block around this line of code, or I can simply use a catch also. So because we already have a try here, I can have multiple catches. The first one is for file not found exception, because here we're trying to access a file. Potentially, if there is no file exist for whatever reason, we want to handle that situation. So file not found. and then we are reading from the buffered reader. So in that case, we want to handle IO exception, input output exception. For whatever reason the buffered reader was not able to perform, then we need to catch that exception. So these exceptions are automatically you can add based upon the Eclipse suggestion, which we will cover in a different lesson exclusively for exceptions. So now that we have read the file using buffered reader, file reader and buffered reader, now let us try to print this line. As of now, if we run this code, this method is not being called. So we need to add that line of code in our main method so that read method is also getting called. Now let us run this, and we have got an error, file not found exception. See test auto, test automation, test file, system cannot find this file. Let us see, right click properties and see what is the location. See test auto, test automation, test file. So here it is test file.txt, and here it is saying tst file. So there might be something we did not type well. So here I did new file, test file. So what I'm missing? I'm missing .txt. So let us add that and rerun. And we can see hello got printed here. So only the first line got printed out. If we want to read all of those lines, then we have to loop through the new lines in that file and retrieve one by one. For that we have to use a while loop. So let us do that. So in this statement, this part will get evaluated first, which is trying to read the line from buffered reader, and if it has some value, let us say hello, hello is not equal to null, then print hello, and then again look for the next line, and if there is some text which is not equal to null, then print it. Then let us assume it approaches the end, which means br.readLine will return null. That means a null value is written, and null is not equal to null. In that case, the condition failed and it will come out of the loop. So it won't try to print it. Let us try to run this and see how it goes, and we are supposed to see the multiple lines. So here we are, we have hello and test automation, 2 lines we have, those are printed out here. And in this example, we have seen writing to a file and reading to a file. We have used 3 different built-in classes. One is file and file reader writer, buffer reader writer. For writing, we have used buffered writer, while reading, we have used buffered reader. I highly recommend going through API documentation of file class. It has a lot of valuable information, so you can Google Java file class and you can see the various methods available on it. Let me pull it up. We can see various different types of methods that were available, like can execute, can read, get absolute file, get absolute path, is directory. This is one of the important ones. If you want to check on a particular path, whether it's a directory or a file, you can use is directory. And if you want to check if it is a file or not, or if it is a directory, it's like opposite of this one. Is directory, is file. And list will give us a list of files in a folder. So there are a whole bunch of methods that are available. Just browse through them, and you may or may not be using them, but you will get an idea what are the possibilities within the file object. I will attach the source code right next to the lesson. You can play around with it. With this, I will conclude the lesson. You may now move on. Thank you. Hey guys, welcome back. In this lesson, we will discuss a couple of things. Running a program from command line, reading values from command line, passing arguments to main method, reading user input from the command line, and writing back to the command line. This will be one of the interesting lessons. You know why? We will run our program from command line, the bare bones way of executing the code. We won't be using Eclipse run as Java application, but we will run it from the command line. Eclipse is great, but to understand a program at a very root level, running from the command line gives us a better feel. Java allows us different forms of input and output. We have seen creating a file, writing to a file, and reading to a file. And also we have seen reading properties file. These are all input and output operations we can perform using Java. Reading and writing from command line is another way of input and output operations. We will be using scanner class of Java to read from the command line. In the very first step, we will create a Java class and it will print hello to the screen. Instead of running from Eclipse, we will run it from command line. Let us get started. Creating a class by name commandline.java, in which we will add one system out statement, and then we will go to the command line and run it. I have saved this file. Now to run it from command line, we need to know the exact location. So I will right click, and in properties, we can find out the location of this file. We need to go into this directory, and from the start menu, type in cmd and open your command prompt. cd into the directory where the class file is, and here I will do dir command to see what are the files in here. There are a couple of files, but we are interested in command line.java. So here is one important thing to note. When we are running from command line, you need to compile the code first and then run it. So Java provides javac command to compile the code. So you will be running the command javac and the file name. That will compile the code. Now we need to run the code by using java command. For that, we need to specify the package name. So what we will be doing is we will be doing a cd ... one step lower, and we will be running java command with the java and the package name java fundamentals dot command line. So that will run actual code. So we can see testautomation.co got printed out. Simple and nice, isn't it? So now let us take it to the next level and make it more interesting. We will pass values into the main method so that our program will collect that information and print it to the screen. For that, we need to go back to the main method here, and this main method is designed for accepting values from command line. What we can do is we can add a line of code which will collect the information that is being passed to the main method. So you can notice here in the parameters that string array of arguments. That means this main method can take multiple arguments which can be passed as strings. So for now, let us start with 1. I will pass in a value into this main method which we want to concatenate with this message and print it to the screen. Let us pass a salutation or a greeting into this method which will be concatenated before testautomation.co. Since we are passing only one argument for now, that can be captured by going to the 0 index value of arguments variable. So what we can do is we can simply do args at index location of 0, which is the first argument from the command line, and simply concatenate with the existing one. I will save it and do Control Shift format, and now we can go back to the command line and run it. Here I'm going to do one mistake intentionally to show the common problem the people will face, which I'm trying to run the command javac and passing in the value, let us say good evening. And we don't see good evening test automation got printed. Why? Because we ran the code directly, but since we made changes to the code, we need to first compile the code and then you can run it. Compiled. And run it. Now we can see the salutation appeared before testautomation.co. What if you want to send more arguments? Well, you can definitely do that. You can keep on adding args with an index of 1, 2, 3 so that you can pass multiple arguments. Since this is a string array, you can send multiple arguments into the main method. In part 2 of this lesson, we will prompt the user to enter the value. So far we are passing the values as an argument. In the next lesson, we will prompt the user to enter certain values. We will take the values into the program. With this, I will conclude. the part 1. We'll see you in part 2. Thank you. Now we want to prompt the user to enter the value. For that, we need to use a class in Java called scanner. Scanner will help us in reading the values whatever it was entered at the command line. I will quickly create a new class so that they can remain independent. So copy command line and paste it in the same package, and I will rename it as command line scanner. In here, I will eliminate this piece of code which is reading from the command line and introduce scanner. So to read from the screen, like I mentioned, we need to use a scanner class. So here in this line, I will try to read a value, but before that I want to prompt the user to enter a value. For that, I will write a sysout statement saying please enter salutation you want to use. And here I want to capture whatever the user entered. So let us run this code and quickly see how it goes. So we can notice we are prompted to enter salutation. So here I will enter, let us say, good evening. Since we did not concatenate that variable with the test automation.co, it did not show up as one single line, which we can fix. I'm going to concatenate the salutation with the text we are sending it back to the screen. And actually we can try one more prompt. This time let us change it to please enter your message. And we will capture that into a different variable, let us say message, and we will take that message variable and concatenate here towards the end. So we are taking two inputs from the user by prompting the user. One is please enter salutation and another one is please enter your message. Now let us run. This time we are supposed to see everything together in one single statement. Compiling the code with Java C. Compiled, and now I'm going to run it. The first prompt, I will type in good evening, and we should get the second prompt. I will type in thank you. So we can see good evening test automation, thank you. So the scanner object we are using here will wait until the user input is received. User input in the sense a text and then the enter key. Then only it will go into the next line of the code and executes it. So this way we are prompting the user to enter values and we are collecting that values into the program using the variables salutation and message. With this, I will conclude the command line lesson. So far we covered running from the command line, reading values from the command line as arguments to the main class, reading user input from the command line using scanner object, and of course by writing it back to the screen using sysout. You may now move on to the next lesson. Thank you. Hey guys, welcome back. In this lesson, we will learn about reading a properties file. It is very common in Java Enterprise development to use properties file. So what is a properties file and why we need it? A property file is a simple text file in which you can store the values, which we call them properties. So these values can be a pair of parameters, a key value pairs. One storing the name of the parameter and the other storing the value of the parameter. Usually we use extension .properties for the file, but you can also use .config. So why we need properties file? Properties file will allow us to externalize the data. So you can put certain values in this file and access it as required, so that you don't have to recompile the whole program if the values changes. So the main purpose is to keep the values independent of your program and use it whenever required. Also, you will be able to change it whenever you want to without rebuilding the application entirely. I will give you two examples. One of them is to store the URLs for the test environments. Let us say we have 3 test environments. One is QA environment, another one is staging environment, and third one is production environment. So for all these 3 environments, you will have 3 different URLs for your application. So these URLs can be stored in properties file, and whenever there is a slight change in the URL, you don't have to change the code, simply change the properties file. And the second example is to store the path to the drivers. When we are doing Selenium, you will use different browsers like Chrome, Internet Explorer, Firefox. So we need to download the drivers and put them in a certain path in our computer. For that, you need to give where the driver is located. That file path you can give it in properties file. So for Chrome, I can give C:\Chrome driver, and for IE, C:\IE driver. Whatever the executable name path is, you can give it. Whenever you move the driver for whatever reason, you don't have to change it in the code because it's part of the property file. You can simply go into properties file and change it to the new location. Now let us create a Java class which can read the properties file. So we have 2 components here. One, the properties file itself, and the Java class which accesses the properties file. Let us start with creating a new class by name readProperties. So this class will be used to read the properties from the properties file. Here I will select the main, and let us create a config file which stores our configuration URLs. For that, I will right click on source and add a new source folder. The name I will give it is resources. So typically a resource folder in Java is something that stores those files which are not the source code. It can be properties files, it can be images, anything else but not the source code, like not .java extension. So in resource folder, I will create a new file by name config.properties. I will select a simple file here and I will name it as config.properties. So this file will have all of our URLs. It can be anything. So in our example, we are trying to store URLs and path to the web drivers. So let us start with storing URLs. I'm trying to give close to the real-time environment. So these are the three different URLs we want to store in this config.properties file. Let us save this and let us go back to our Java code. Here in Java code, we will be using 3 inbuilt classes from Java, which makes our life easier. So as a developer, you should be knowing certain packages or classes available in Java. You need to know that. That comes with the practice, right? So first of all, you have to think if certain problem arises, is there anything in Java that I can really use? Just Google. So for loading a file, is there anything I can do about it? In our case, we will be using something called class loader. Class loader is a Java runtime environment class which loads the files in the runtime. So when the application is running, all of a sudden we were looking for QA URL, then we need it. In that case, we will use a class loader to load that file for us. You can simply open the file and close the file by using file IO operations, but class loader is more efficient because you're not holding to the resources. You're just loading it just in time. So for class loader, the syntax will be class loader thread.current thread and get context class loader. Let us write that down. And using this loader, we will load the file we want to use. So loader dot get resource as stream. So here we can give the path or the file name for the file which we want to load. We want to load config.properties, right? This particular get resource as stream will return back a stream. So if you mouse over here, you can see the return type as input stream. So we need to get hold of that stream so that we can access config.properties. I will name it as just a stream, or you can name it as prop stream. So I'm going to import input stream here. And the third step is basically we want to use this stream into the Java properties class. I will declare a properties class now. Here we go. So there are three different classes, built-in classes of Java we are using. One is class loader, and then input stream, and then properties. The beauty of class loader is you don't have to deal with the path of the file. So it basically, if your file is on class path, this class loader will load for us. This will save a lot of headache if you're using class loader. Otherwise, you can also simply use file input stream, try to open that file and access the properties. That is definitely possible. But the problem with that approach is sometimes you will run into issues with the path issues. So you have written code on Windows and then you're running on a different environment, but the path separators like forward slash, backward slash, you will run into that kind of issues. So you better use a class loader when you're loading a file, and make sure that file is created in such a way that it is a source folder. Okay, initially we created a new source folder, remember? So use this approach rather than simply using a folder approach. This will not be on the class path. We want the folder to be on the class path so that class loader can access the file without you giving any path. You see, we just gave the file name, that's it. We did not do anything like C:\workspace or C:\properties. We did not do that. There is no C: exists in Linux environment. So we don't want to give absolute path in the source code. To avoid that, we are using class loader. Hope you got it. And so finally we are here with the properties.load. So here when I mouse over, it is giving two options. Do you want to throw or surround it with try catch block? This is basically whenever you're reading a file from a location, there is always a possibility of file not being there for whatever reason. That is why it is required to use exception handling. For now, I will use a try catch block. Just click on that. So this is where we are loading the file. For whatever reason this file does not exist, we will get this exception, IO exception. Now life gets much easier. So if I want to read any kind of property, the properties class will provide certain methods we can use. For example, prop.getProperty. So I can use this getProperty method and pass in whatever the key value is. That would be, let us say, we want to get QA URL. Let us make sure the name is the same, QA URL, and we can get that. Similarly, we can also get the different properties from the properties file. Dev URL, semicolons. Let me print it to the screen so that we can take a look at it. And let me run this code, run as Java application, and here we go. We can see these two URLs retrieved from the config.properties file, and we have written them to the screen. So the greatest advantage of using properties file is basically without touching the code, I can change the config.properties file, and that will be effective for us. So if it is hard-coded value, I need to go into the code, change it and save it. But since now it is part of config.properties file, I can simply go here and change it here. I don't have to really change anything in the code. So for example, the QA URL changed to qa.testautomation.co, right? And I will save the config file, but I haven't touched anything in the Java file. Let us right click, run as Java application, and we can see that is reflected in the output here. The newly changed value qa.testautomation is reflected here. Similarly, we can use it for different purposes. whether it's a driver location or database URL or simply the test environment URLs, you can all combine together into this config.properties file, and you can change whenever you want to without touching the code. So that gives us a lot of advantage not to recompile the code every time, but simply you can use the config.properties file to change the code. So the common question I get is, for the first timers, is why we need class loader. So it's a Java runtime environment class file which loads the resource in the runtime, so that we don't have to hold on to the resource all the time within our program. We will just use it just in time, and you don't have to worry about the path for the file location. So I have written this code on Windows 10. I'm running on different environment, different path structure. It still works like a charm, because this particular config.properties, we are loading it using class loader by keeping config.properties as a source folder. With that, I will conclude this lesson. Thank you. Hey guys, welcome back. In this lesson, connecting the dots, we will recap our knowledge in this Java course, connecting the important topics we covered in this course. For any skill or craft, we need to start with choosing right tools. Similarly, for our Java development or Java learning, we should start with using the right integrated development environment. Eclipse is a very popular IDE where you can write code, compile and run at the same place. On top of that, IDE provides help with method name suggestions, syntactical errors, possible runtime exceptions. So these are various advantages we have by using IDE. Getting familiar with Eclipse is very advantageous if you want to code faster and efficiently. So the very first one is Eclipse IDE, and then next one is variables. Variables are used to store information to be referenced and manipulated by the program. They are the temporary storage, where you can store the values and manipulate them before being processed into a different output. When we talk of variables, we need to talk about data types. The various data types we have seen are string, short, int, boolean, and some other variable types are byte, long, float. These are the different types of variables. So connecting Eclipse to the variables here. Number 3 is methods. A Java method is a collection of statements that are grouped together to perform an operation. A method will take parameters, and a method will also return values back. If you consider an object in Java, variables carry the data and methods will execute actions on the data. Access modifiers. Access modifiers helps to restrict the scope of a class or constructor or variable or a method. You can declare an access modifier for various components in a class and define which method is accessible outside of the object and which is only accessible inside of the object. If you want to declare a variable at a class level, that variable will be accessible in different methods in that class. If you declare a variable in a method, it is only accessible inside the method but not at the class level. You have to decide which access modifier to use based on the scope of that particular variable. Different types of access modifiers are private, protected, public, and default. Default is the one that you don't use any keyword. Conditional statements. Conditional statements allow us to check a condition and then decide to execute certain parts of the code. Generally, conditions evaluate for true or false. For example, if else is one of the conditional statements. If in the parenthesis you will evaluate for a true or false condition. Typically we use a comparison operators such as equal to, greater than, not equal to, and also checking for null conditions if certain object equal to null or not null. Based on the return type, we will decide whether to execute the following statement or to go into the else statement. All of the logic we write in the programming languages depends upon conditional statements and loops. Coming to loops, loops facilitate the execution of a set of instructions repeatedly while condition evaluates to be true. Java provides 3 different types of loops: for loop, while loop, and do while loop. While all of these 3 provides similar functionality, they differ in the syntax. Generally, we use loop to execute continuously a particular set of instructions until a certain condition is met. For example, iterate through the array list until there is no more object in the array list. You can use enhanced for loop to iterate through array list. Logic building. Logic building is most essential skill of programming. Logic building involves solving a problem using code and syntax of the language. Simple example is printing all the even numbers below 100. For this, you need to think through how to find the even number. All even numbers, when divided by 2, the remainder should be 0, right? So we will use a loop that goes till 100. Inside the loop, we will divide each number by 2 and make sure if the remainder is 0, we will print it out to the screen. Another non-mathematical example is making a list of employees based on their department. So in an array list, we have this list of employees, let us say 100 of them, and we want to make separate lists each for department. For IT, one list, HR, one list, executives, one list. You can build logic by thinking through the problem and sketching out how you handle it before writing the actual code. And then once you decide to write the code, you need to see what are the existing libraries of the programming language you can use and how you should use the syntax. So logic building is a combination of the programming syntax, libraries of that programming language, and the logic itself. String handling. String handling is a concept of storing the string data in the main memory, manipulating the data of the string, retrieving parts of the string, truncating, getting the trailing and leading parts of the string, various kinds of manipulations to it. String handling provides a lot of manipulations and actions that you can perform on a string. Programs deal with data munging all the time. Sound knowledge of string handling is very core to learning a programming language. Collections. Java collections framework allow us to use right data structure for our particular needs. For example, you want to store key value pairs. You will be using hash map. You are going to use a list of objects to be stored. Then you will be using array list. And the lot of functionality that comes with the collections is not available in primitive data types. The primitive data types like int, boolean, float, etc. Collection is a container which is an object by itself that can group other objects into a single unit. So if I want to build an employee list, I can build an employee list with employee objects, and I can retrieve them by going through that list. On top of that, it provides a lot of convenient methods like add, remove, sort, which helps with saving time not to code from scratch again. Classes. Everything in Java is associated with classes and objects along with attributes and methods. A class is like an object constructor or a blueprint for creating objects. For example, in real life, a car is an object. The car has attributes such as weight, color, and methods such as drive and brake. A design specification which provides all of the details of the car can be considered as a class. Objects. Java object is a combination of data and procedures working on the available data. An object has a state and behavior. The state of an object is stored in fields, also called as variables, while methods display the object behavior. Objects are created from templates or blueprints, which we call them as classes. A class, when instantiated, it becomes an object. Constructors. A constructor is a special method of a class in object-oriented programming that initializes an object of that type. A constructor is an instance method that usually has the same name as the class and can be used to set values of the members of an object. It will be the first method that will be called automatically when an object is instantiated. Abstraction. Abstraction is a process of hiding the implementation details and showing only the functionality to the user. In Java, abstraction is achieved using abstract classes and interfaces. Encapsulation. Encapsulation in Java is a mechanism of wrapping the data, which are variables, and code acting on the data, which are methods, together as a single unit. So we are encapsulating variables and methods as a single unit, which is nothing but a class. In encapsulation, the variables of a class will be hidden from other classes and can be accessed only through the methods of the current class. Therefore, it is also known as data hiding. Inheritance. Inheritance can be defined as the process where one class acquires the properties, methods, and fields of another one. With the use of inheritance, the information is made manageable in a hierarchical order. The class which inherits the properties of other is known as a subclass or derived class or child class, and the class whose properties are inherited is known as superclass or base class or parent class. The keyword for inheritance is extends. Polymorphism. Polymorphism is the ability of an object to take on many forms. The most common use of polymorphism in object-oriented programming occurs when a parent class reference is used to refer to a child class object. Any Java object that can pass more than one is a test condition is considered to be a polymorphic. Let us say we extend deer from animal. So deer is a animal. And we also implemented vegetarian. Deer is a vegetarian. So we have passed more than one is a condition. We can consider the deer object as polymorphic. We can perform polymorphism in Java by method overloading and method overriding. Interfaces. It is similar to a class. It is a collection of abstract methods. A class implements an interface, thereby inheriting the abstract methods of the interface. Abstract classes. Abstract class in Java is similar to an interface except that it can contain default method implementation. An abstract class can have an abstract method without a body, and it can have methods with implementation also. Abstract keyword is used to create abstract class. Abstract class in Java can be instantiated. An abstract class is mostly used to provide a base for subclasses to extend and implement the abstract methods. Package. Package in Java is a mechanism to encapsulate a group of classes, subpackages, and interfaces. Packages are used for preventing the naming conflict, so an employee class can exist under a package employees, and it can also exist under a different reporting package. Even though they have the same name but they are part of different packages, we don't see any conflict. And also packages help with grouping so that the similar classes will be grouped together into a single package. Import. Import keyword is used to import built-in and user-defined packages into Java source file so that your class can refer to a class that is part of another package and you can use it in your current class. File I/O. This package provides for the system input and output through data streams, serialization, and the file system. For instance, you can read data from a file or over a network, write to a file, or write response back over the network. We have seen an example where we create a file, read from a file, and write back to a file in one of our lessons. Properties. Properties is a utility class provided by Java which we can use to read the configuration properties from a file. For example, config.properties or application.properties, which will have the configuration and constants located as name value pairs, which we can read from the properties file in the runtime. Command line. From command line, you can run Java program by optionally passing arguments to the main method. You can develop an independent utility program which takes arguments from the command line and process the data. Using scanner class, you can also take user input. The one advantage of command line is you can run the program without using Eclipse IDE. Java exceptions. An exception is an unwanted or unexpected event which occurs during the execution of a program, that is at runtime, that may disrupt the flow of the program. But you can handle these exceptions by using try-catch blocks. That way we can avoid runtime exceptions. Hey guys, welcome back. In this lesson, we will work on Java mini project. The main purpose is to implement the skills we learned so far in this course, and we will incorporate them into this application. So what is the main requirement of the project? Every project starts with a requirement. So the requirement for this project is to create employee from command line and list all of the employees and exit from the application. So three main actions we have to do from the command line. One is creating a new employee, listing the employees and exit from the application. The core of this application is employee object. That is what we use to create employees. And the second important thing is running this from the command line. In our previous lessons, we have seen how to run from the command line. And at the same time, we have created employee object in the past. And also we have used setters and getters. To keep this project independent, I will create a new package, and within that new package we will create employee class, and the employee class will have methods such as name of the employee, department, title. Let us start with creating a new package under the source folder. I will name this package as mini project. And in this package, we will create a new class employee. Within this employee class, we want to have 3 variables which handles name, department, and title. So for those, I will declare the variables inside the employee class. Can you guess why I declared the variables as private and not public? Yes, you're right. We don't want to expose the data directly. The recommended way to update data is by using methods. Remember, encapsulation only expose data through methods. So to create setters and getters for these variables, Eclipse helps us a lot. You can simply right click on the variable name and go down to source and select generate getters and setters. Once I select that, you can check for which variables you want to generate setters and getters. I have selected all 3 of them and I can click on generate. So now it puts right next after the name variable. Let me cut this part and paste it right below the variables. You can see the auto generated code for us, which is very convenient. We have get name, we have set name, get department, set department, similarly for title. And whenever there is a get name or get department, there is always a return, because we're trying to get the value. When we are setting the value, we always pass a value to the method. So here we're setting the name by passing a name value, which will assign that name to the variable name of this object. So employee is a class right now. Once you instantiate, it becomes an object. You can create any number of objects from this class, right? There's a class and object relation. Class instantiation will become an object, and class is a blueprint where object is the implementation of the blueprint. Well, with this, we have our employee class ready. Now, let us write code to take care of user input for creating employee object. So for that, we need to create a new class which has a main in it that we can run it from command line. So for that class, Let us give a name HR manager, hrmanager.java. So under the mini project itself, I'm creating a new class by name HR manager, because we are managing employees by adding listing employees. And this will have the main method, so I select this public static void main and finish. So let us pause for a moment and think of what should go into this method. This is the method that we will run from the command line, and we are supposed to prompt the user to enter or select certain things. Since we are trying to add an employee, we want to collect information such as name, title, and department. So these are the three inputs we require from the user, and based on the input, we will create our employee object. So we will be using the scanner class in Java to prompt the user to enter the values. Let us start with the questions we want to ask. I will start asking the user, enter the employee name, enter the employee title, enter the employee department. So here we are collecting the information of the employee name, department, and title. Now it is a good point to run it once and see if there are any kind of errors in it. So at this point, you don't have to really go to the command line. You can simply run it from Eclipse and interact with it from the console itself. Right click, run as Java application. Here we can see it is prompting for employee name, department, and title. So let me right click and run it one more time. So we can enter those values for the prompts here. Previously my cursor was in the code area, so I need to move the cursor into the console area and we can enter those values. The next step is adding this employee information to a employee object. Right now it doesn't make any sense. The information is simply sitting in these variables, right? If you want to add more employees, and also if you want to tie the information together, so this is the information of an employee Anand and his department and his title, so this should be tied together. We can do that by associating with employee object. So next step would be creating an employee object for this employee. So we will declare an employee object here. And start adding the values to this object using the setter method. So employee dot set name should take the name variable. which is coming from the end user from the command line, and similarly we will set the values for rest of the variables. So we have successfully created an employee object based out of the command line input from the user. Now we want to ask the user again, do you want to add one more employee or exit from the application? We want to check, right? So for that, we need to use a loop that will continue until the user says exit out of the application. So let us try implementing a loop which will prompt the user to either add employee or list employee or exit. So we will add the loop at the top. That's where our questioning the user starts. So I will be using a while loop, while true. When you say true in the condition, that means it always go into the loop. Let us start like that. So here we will ask the user the question to start with. What you want to do? Do you want to add, list or exit? I will keep the verbiage simple. So sysout this is the question we are asking the user. Then we need to receive the response, right? So let us move the scanner up here so that we can use it inside the loop. Okay, this is where we are collecting the user input. Whatever the user types in, maybe add, maybe list, maybe exit, right? And this curly brace, I will take this off from here and move it down up to here. Control X, Control V. So that whatever the action we want to take, all of the code is available for us. So for example, right now, let us say we need to evaluate each individual case. Let us assume that user wants to add an employee. Then what we can do is, this is the user input. If user input dot equals add, then perform this add process, right? Control Shift format so that it looks nice with the indentation. You can move the cursor right before the curly brace so that you will know where it is ending. So this if statement is ending right here, and I'm interested in while loop. While loop is ending here, which is good. Now add is taken care. What about exit? Because if the user selects to exit, there is no point in passing through the add process. So obviously we want to evaluate that right after you get the user input. So what I will do is, if user input equal to exit, simply come out of the loop, right? There is no point of executing any further. So for coming out of the loop, we will use break. Since break does not show anything on the screen, let us add something that makes sense so that we know we are exiting. So I will add something like bye for now. Now we are at a good state to check our code. So let me run this code, run as Java application. So we can see the prompt here, add, list or exit. We did not implement the list functionality, so don't worry about it for now. Let us say I want to try exit and see how it goes, because we want to come out of the loop. And we can see bye for now, and we are out of the loop. Let us run again and try for add. So we are good there with adding an employee also. Perfect. Now let us take to the next level and implement listing the employees. So if you want to list the employees, what do you need? The answer is in the question itself, listing the employees. We need to use some kind of list, which will be array list. So we will use array list to add each individual employee into it, and whenever the user selects list me the employees, simply we will iterate through the list and print the employees to the user. Sounds good? So for that we need to declare an array list and add the employee object to it. I will declare employee array list at the top here. It is of type employee. So here we declared an employee list which is of type array list, and take that variable and bring it down here. Whenever we create a new employee, we want it to be added to employee list. So we'll simply add this employee to it. Listing an employees will be nice and easy if you use enhanced for loop. So we will be using enhanced for loop, which is will be iterating through the list, which is emp list, and within this for loop we can simply get the values for each employee. So I would be doing something like emp dot get name, emp dot get department, emp dot get title. And to separate from each employee when we are listing it, I will use some kind of separator. So let us do sysout and simply add few dashes. Okay. Now let us try to run this from Eclipse itself and try to see if we get the list back. Okay. Right click, run as Java application, and here I will select add and employee as John, department IT, title as det. What you want to do again? So since we are in the loop, now we are getting this prompt back, because once this while condition, if this part is done, it will come back to here, and again it will prompt for the user input. Now what I will do is I will select add again, and now I will add a new employee. Let us say Raj, department HR, title manager, and again we see the prompt. Now I will select list. Let us see how it goes. Whether it bombs or will it work. List. So we can see the list executed twice and we see only dashes and we are not seeing the values. Probably because we did not do a sysout on these values. We are getting them, but we are not writing them to the screen. Let me quickly add the sysouts and we should be good. I have added the sysouts here. Let us run it again little quick. Add. Add again. Now I will list. We can see John ID as dead, Raj HR manager or listed. Now in this step I will simply exit. So we are out of the application. So we have seen adding, listing, and coming out of the application. All three of them. I will stop at this point of time and we will see running it from command line in a separate lesson. But pretty much the coding part is done. So this particular application met our requirement, and here I will give you one assignment, which is delete an employee. How do you delete an employee? So we have done add, list, and exit, right? I want you guys to try delete option so that a particular employee will be deleted out of the list. Try that by yourself, and in the next lesson we will see running this from command line. Thank you. Now let us run mini project from the command line. For that we need to know the location of these files. So I will right click, properties, and find out the location. And opening the command prompt, we will cd into this directory. Let us list the files in this directory by using dir, and we can see hrmanager.java and employee.java. Let us compile these files. Two-step process. First we need to compile and then we will run hrmanager. For compilation we will use javac. And for compiling HR Manager, we need to step out of this folder and run it, because HR Manager uses the reference of employee.java. For that purpose, we need the full folder access to compile it. Let us see what happens if I try to compile from this same directory itself. So we can see here, cannot find symbol employee. Employee is not accessible if we are simply running only hrmanager.java. So for that, what we have to do is step out of this folder and javac mini project hrmanager.java. We will run it from here. So we have compiled hrmanager.java also. Now it is time to run HR Manager. For running we use Java command without C, just Java. mini project dot HR manager. So now we are able to see the first question our program will ask: do you want to add or list or exit? So here I will select add and fill up the questionnaire. I'm adding one more employee. Now let us list the employees. So once I listed, I can see John IT SDET, Kate HR manager, and now finally I will exit from this program. Exit and bye for now. So from the command line, we have compiled the files, ran HR manager class, and ran the program from the command line by adding employee, listing employees, and exiting from it. So with this I will conclude the lesson, but you can work on delete an employee an option. So right here we have add, list, or exit, right? Add, delete, or list, or exit. Add one more option. That option should delete an employee from the list. When you do list, before and after the delete, you should see the difference. Anyway, I will provide the solution for it. Give a shot by yourself. Thank you.